Okay, are we live? Yep, looks like it. Cool, so welcome back to my game engine development stream. So where did we leave off? Yesterday, we got started with a new YAML library. I think I'm probably going to keep it. We're going to keep using it for the moment for this specific task. And we had transitioned from using PNGs directly as textures to using texture asset files. Right now, it's a little bit crowded and a little bit hard to parse because I have them all listed together with identical icons in the content browser. But if we take a look at these files, the .ep text files are now YAML files that reference the texture and also set the texture's properties. And that allows us to do things like this. Let's open up text2, wtext. This is a YAML file which has got some comments in it, but it's a YAML file with the min filter, mag filter, map mode, and we can now change these to being something else. This is the link sprite. If I change it to say linear and save that, and then I go to reload the scene like this, you'll see that all of a sudden we have a blurry link because we changed his magnification filter to be linear interpolated instead of nearest pixel. And yeah, that's helpful. The ability to split off textures into asset files allows us to work with materials better. So one of the challenges with materials is that you can have a variety of texture types. You need to make sure that you're assigning, when you're working with a material, you need to be sure that you're assigning the correct type of texture to it, which means that you need to be able to specify a texture array, a 3D texture, and a variety of other formats that take multiple image files. And if you do reference counting with simply the image files, then which image file do you reference count? It gets complicated. But now it's suddenly gotten a lot simpler because now we can just use a single asset file to do a texture array or something along those lines. And it would be a one-to-one correspondence between the asset file and its use case. So we can have link here be in multiple assets, and I should change the PNG file, and he will update in all of those assets, which is good. That's useful. I went and revised a little bit of the code from yesterday. Mostly the only thing that I had done was moved the reference counting to be handled by the EP texture file, whereas before we started doing all of this, we were loading the PNGs directly, and we used the path to the PNGs as a handle by which we can count references. And now, instead of doing that, when we go to load the texture, we do a reference count based on the path to the asset file. And then if it's not available, or if it's not already loaded, and we can't just increase its reference count, then we will load up the texture YAML file, and then go from there to set it up with all of its properties, such as minification and magnification filters. So don't think there's much more to show off before we continue. I have identified a bug that I do want to fix, and it turns out that it's not, at least at first glance, it doesn't appear to be that the bug is related to the texture system. It seems to be related to renderer 2D. When I go to load up second scene, nothing appears. We see that all the sprites have been replaced with alt sprite, but none of these have sprite components on them, and that's because they failed to load. If we take a look at the console, we get all these warnings popping up. It says the root node of the texture asset file is not a map, and this is because the second scene file is still linking to PNGs instead of texture asset files, and so it'll fail to parse them as YAML files. that's all well and good. We don't want to load something that we don't want to create a sprite component that doesn't have a working texture on it. So that this is an example of that working. The problem arises from trying to open up a valid scene again. We get an assertion saying that we're trying to release a null texture. So I think there's something going wrong with Renderer 2D's tracking of sprites. Hey, Person Med, welcome in. This is my third day in a row streaming. I don't usually like to do back-to-back streaming days, but I'm kind of just ready, kind of in a mood where I'm ready to code, you know? Yeah, so that's that first bug that I mentioned. I'm gonna fix that first because it's gonna be annoying if I don't. Even though we still have plans to overhaul Renderer 2D once the material system is finished. Then I have two other goals today, and that would be to split off the texture setting that is setting up properties on the texture from the texture loading. Yesterday we had done a fix. If we take a look at the content view code inside of the engine layer, we had to make it a little tweak to how we loaded up the folder and file stuff. So the folder and file icons were previously being loaded with the same API that we used to load textures in the game. It's now using the hidden implementation function directly. And what this does is it bypasses reference counts. And it also bypasses the need for creating a texture asset file. So when we're working inside of the editor doesn't actually itself use the YAML-based texture asset files. What it does is it just loads the PNGs directly. And that's good. I think that's the way that I want to do it. However, we're soon going to run into the situation where we want to edit the texture assets, the texture asset files, the YAML ones, inside of the editor. And that means that we want to see some of these changes occur in real time. We don't actually need to reload the texture just to change its filter. We just need to bind it, and we just need to change its property. So I want to split off this functionality to a separate set of functions, and that way, when we are ready to do the texture asset editing, so you can select the asset in your content browser and then change it in the inspector to use linear or nearest or anisotropic filtering or something like that. Those changes can be observed in real time, and we don't have to reload the PNG. There's going to be a separate process for reloading PNGs if we want to go that route, but that's going to be the next goal. And then we need to worry about types. So up until now, every texture that Enterprise has supported has been a 2D texture only. So just like a sprite or a surface texture for a 3D model, or font atlas or whatever, it's always been 2D. However, we're going to need to support additional types. So that means things like that texture arrays, so 2D or 1D texture arrays. We need to be able to support doing 1D textures, 1D texture arrays from 2D images. We need to be able to support sprite sheets. We need to be able to support cube maps. So for all of those are going to be things that we define inside of the asset file. And if we take a look back at the original design here, let me do Control KM for changing the language, set to YAML, uncomment these. This is the design we came up with some episodes ago. Basically, we will, instead of just doing a singular path, we can list several paths. And instead of just doing one image per layer, we have the ability to slice up for the sake of arrays and stuff. We specify the type of texture that we're using up here, 1D, 2D, 3D, cube, 1D array, 2D array, and cube array. There's no 3D array. And then we use this to determine whether we support slices. So the texture types that will support slicing are everything but 2D. Everything but 2D, actually. So when you're making a 1D texture, you could take and slice up a single texture file into a bunch of one row images. So you can take and like pack a texture with a bunch of gradients that you would use for different situations in your game, and then use that one file and split it up into a array of 1D textures. And that's going to be done with slices. 2D doesn't exactly apply. If you're slicing a 2D image, then you're going to be putting it into an array or 3D texture. We are on different levels, I see. Yeah. This is stuff that's still very new to me. I haven't ever made a robust engine like this before, so I'm having to think about these topics in like a very general way, and like thinking general purpose. How would I arrange everything, but still make it capable of doing all the low level stuff? You're going on about texture slicing. I'm going on about hashing graphics adapter LUIDs. Yeah. Just different topics. But yeah, so 2D doesn't really apply for slices, because what would you slice into a 2D image? It would have to be by definition one slice. Well, 1D doesn't actually apply either. Okay, I'm getting off track, but basically the idea is that you can specify paths and slices. Each path that you specify adds a layer to the texture asset that you're working on, and the slices will subdivide those into more slices. So if you take and specify five columns and 5 rows, please, then you will get 25 slices out of a 2D image, and those will go into layers. And if you have more than one texture, then the first 25 will be from this texture, and then the second will be from this. I think that's pretty good, general enough situation. So we'll have to get that working today. Got quite a build system going though. That's cool. Yeah, I'm not really sure what an LUID is. What is a LUID? Let me undo all these changes and save. Yeah, these are the 3 things. Yeah. So bug fixing first. Locally unique identifier. Oh, okay, that's interesting. Huh. Why would you? I mean, just hashing it just to have a hash for hash tables or something like that. Hashing graphics adapter LUIDs. Only 64 bits large. Only 64 bits. Yeah, I know you can do wider, but in game engines, it's like, why would you do larger than one number, or one variable? Which makes hashing easier with 64-bit ints. Yeah. We do a little bit of that ourselves. I'm not really going to be changing up my hashing function, but at some point I'm going to need to change how I intern the hashes. But we'll come back to that. Hashing the LUIDs to detect if your graphics adapter setup has changed since the last time the engine ran. Yeah, that's a good one. Yeah, that's a good use for that. But yeah, 64-bit hashes are just like so much more than what most people need for simple things like that. 32-bit hashes, virtually you'll never get collisions, from what I understand. But 64-bit hashes are like still theoretical. 64-bit hash collisions are still like theoretical. planning on some advanced configuration to select what adapter you want to use for rendering. That's pretty cool. Yeah, that's pretty dope, man. Yeah, I'm a huge fan of making robust systems that just take care of you. I just take the 64-bit LUIDs and XOR them together. Oh, okay. Yeah, that's one way to do it. So I'm actually going to go grab my coffee real quick. It's been brewing while I've been talking here. I'm not going on break. I'm just going to leave the screen running and grab my cup. And then when we get back, we will fix the bug that seems to be arising from the renderer 2D failing to correctly load sprite components. I will be back in a minute. Sweet. All right. Got my cup of joe. Let's do this. So I've loaded up the regular scene. I can load and unload the scene just fine. The problems start when I go to load this guy. And it fails to load. I get those warnings. And then I double click and open up the original scene, and it tries to unload the second scene, the one that failed to load, and then we ran into a problem. So, for starters, where does this happen? I have an idea, but I'm gonna quickly double check the call stack. Main thread. Okay. So it's during the call to unload scene file. So immediately after you go to open up a scene file, it closes the previous one before it opens the next one. We go to scene manager, delete entity. We're going through all of the entities to delete them. We're calling the delete component functions for these entities. Oh, hang on. Do we have delete component functions? Oh no, sorry. The delete component function is registered with the system, not the components. So yeah, this is good. So we called the delete component function on every entity. Let me double check this logic. Scene manager, delete entity. If entity indices.count. So if we have a entity index, so that is we have an entity pool. If the ID is associated with one of them, we get the index for it. We then go through every delete component function, and we call it passing in the entity ID. Okay. Good. And then that takes us to the delete sprite component, because the renderer 2D integrates sprite components, and those components pass through these functions when they go to work with the editor. So delete sprite component, we call EP graphics release texture, and that's where we find ourselves. So the release texture call is from the sprite components pool, from the sprite components index, from this entity. Okay, hang on a moment. Okay, so this is empty. Sprite component indices is empty. When we go to call, when we go to use the square brackets on it, we are inserting the entity into it with a value of 0, because that's the default value. Okay, so the problem comes from here. Let's work through this. We have to do an if check, basically. This is probably going to be a really easy thing to fix, so I'm kind of happy about that. So we'll say if sprite component indices.count. C++20 has the syntactically nicer exists call. I think it's called exists. There's a call that's like exists or whatever to indicate that the key actually exists. But count works just fine because it'll be either 0 or 1, depending on whether the key is valid in the map. So if we have that count, then we can do this logic. What about this stuff down here? Sprite components, sprite component indices. So this is still referencing sprite component indices. And so is this. Okay, so if we don't have a sprite component index, then we can actually skip all of this. Sprite component count minus minus. I'm actually going to do a quick experiment. I'm going to leave the logic as it was before, and I want to confirm that sprite component count is 0. I believe that it is, but I just want to make sure that I'm not going off on the wrong track. Oh, come on. How long does it take? Yeah, it took a weirdly long time to compile in like one CPP file. Alright, so let's open up the scene again. Open up the bad scene and then close it. And so here's the call, the assertion failure, because it's telling us it's trying to tell Enterprise to delete a texture that doesn't exist. This is a null texture handle. Going up one level. What is the sprite component count? Sprite component count is 0. Perfect. Okay, so I'm right on track with this. Awesome. So we will take and just wrap this whole thing. Yeah. So I'm presuming that will fix the bug. Let's test it real quick. But I'm thinking maybe it would be a little bit better to handle this at a lower level than the system itself. Perhaps I should... So let's load up the bad scene, and then load up the good scene. Okay, so that fixed the bug. But perhaps we shouldn't be calling release texture. Let me think about this. Probably shouldn't be calling delete sprite component if we don't have... if this entity, in fact, doesn't have the component on it. Because it's possible that a developer making their own system would not think to catch this and wouldn't read the documentation to know to catch it. It's not necessarily intuitive that this would be called on an entity that doesn't actually have a sprite component, because the sprite manager, or sorry, the scene manager is supposed to be managing which entities have which components. So let me take this out real quick. Actually got a better idea. Oh, what's that? Just store the selected adapter's LUID. Yeah, wasn't that what you were doing before? Before you, because like you're storing more than just the LUID, right? You're comparing settings and stuff. That's why you had to hash the entire data block. No, I was hashing all the LUIDs and selecting the adapter off of an enumeration index. Oh, okay. I'm not really following because I don't really know your project that well, but I guess that you were just working with LUIDs. But yeah, as long as it's safe to store or something, you could just store it directly. Okay. Let's head to Scene Manager. Previously, I was doing, when I go to delete an entity, I literally just go through every delete component function and call it on the entity. I don't see how it's not safe. Yeah, it probably is safe in your case. It's the information is safe to store. I'm just saying that like that's not. That's a consideration you have to make when you're deciding to just store something plain. Is whether or not it's a problem. This subject is probably not one of those. I just store it as a 64-bit in the Kung Fu file. Perfect. It's awesome. And for me to actually wrap this, I would have to do a check for every entity that we're deleting. So I basically had to do if, I think there's like a has component function. Check has component functions. there's so many of these. So if check has component functions at, oh, that's a vector, isn't it? Okay, this is interesting. This is a good one. Let me take a look at these. We have a map, two maps with hash. Oh, sorry, this is just a vector. Delete component functions. This is indexed to the system. So that is, as new systems get added, the delete component functions get registered in sequence. So they're index aligned to the load order of the systems. The query component functions and the check has component functions. Yes, these are hashed to the what? Oh, to the registered name of the component. So in this case, it would be sprite would be the name. Okay. So, ooh, this is interesting. I have to come up with, if I want this to work, I have to come up with a way to associate the hash name of the component type with its delete component function. You know what? That doesn't matter to me. It's not important enough for that. If we take a look at the use cases of the delete component functions. Well, yeah, I think it probably will be better in the long run for me to just let the systems themselves handle queries like this. So I will leave it as it was, and we will re-implement the fix that we had before. There might be edge cases that I'm not able to imagine as well, where this would be helpful. If you have a system that cares about when an entity is deleted, even if there's not a component on it, maybe you could handle that. But that's I don't know. That's it's an open-ended system. That's the benefit of it, is that you might, in game development, you're coming up against new problems all the time. Have to do interesting things to solve them. I can't prescribe a solution for all of them, but the more flexible I can make the system, the better. Cool. All right. And so these are the same warnings as before. Could not deserialize sprite component data for entity, blah, 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 blah. All of these little exceptions are coming from format, the format library. The format library is not wrong to be throwing those exceptions, but this comes as a consequence of how it's implemented in SPD log. And so I'm actually just going to straight up ignore it. I will be doing my own implementation for logging soon anyways. So for now, I'm just going to deal with it when it can't handle formatting things correctly. But anyway, so that's the first item on the list taken off. Took a lot less time than I thought it would. Split property setting functions off from the texture loading function. This is going to be a little bit trickier. Let's take a look at it. We are in textures.cpp. So yesterday we had taken and made an implementation function for the load textures. That's this guy. Basically did everything that the previous function did except for reference counting. So this is going to be used directly by the editor layer to load textures. It should never be used by game developers because the whole rest of Enterprise cares about reference counting, so that way it can unload unused textures. But we did need to expose this through the internal header, so that way the editor can see it. In order to make it easier to edit aspects of textures, I need to split off the texture generation part and the texture parameter setting part, which I had so far been doing all at one go. That is, you pass in the path to the image file. You say, well, instances doesn't really apply here anymore. I can get rid of that. Let me do that real quick. But yeah, you pass in the texture handle. You pass in the where's the? Oh, this is not the implementation file. Or the internal. Here we go. You pass in the minification and magnification filter, and then you pass in your bitmap mode, and then as soon as it loads the texture up, it will set these properties, and then it'll be like that until the texture is unloaded. Which is, an okay way to do it, but we're going to be wanting to edit these on the fly in the editor. Because the editor has the power to change the asset, and we don't want to have to reload the texture in order to change it. So yeah, that's removing that one parameter that's not even used here anymore. And then I have to take the parameter out of the load texture implementation call. Okay. And I'll build that just to make sure that it's not broken anything. So where this gets to be a little bit tricky is that these functions will have to deal with binding the texture to a slot as well. Okay, what did I miss? Too many arguments to function call. Oh, that would be the content view. I have been passing in this one because it was required. Now it's not. Cool. So when we are first generating the texture, the texture is already bound. That is, by definition, you're binding the texture that you generate so that you can set its data and properties. However, if it's been in use for a while, you will have to bind it again in order to set the properties. And that means that we're going to have to work in the usage of our slot tracking system, which is a lot more robust now, but it's still a little tricky to make sure that it works correctly. So let's go to the implementation file real quick, and we will start making changes. All right, so the way that this works basically is that we confirm that the image file exists. If it does, we use stbi, stb image, to load it into a buffer, and it's a little tricky because we have to do some checking on it. We have to confirm whether it's a 16-bit file. You can do 16-bit or 32-bit, I think. I can't quite remember. But you use a different stbi load function depending on that. And then at this point, we have a buffer that contains all of the pixels and all their colors and everything ready to go. And so if buffer exists, then that means that it loaded successfully. If it doesn't, then we return 0. Stop it. And inside of the if buffer block, this is where we actually do the generation. So glgen textures, we get a texture handle. We deduce its texture target. So if the image comes in with one row of pixels or one column of pixels, then we've been treating that as a 1D texture. This I'm going to put the note in now to do replace with type parameter in YAML file. Because inside of the YAML files, the asset files, we're going to be doing this. We're going to say type and then say 1D, 2D, 3D, whatever. And so we will prescribe the type from the inspector. in the editor. For now, this is what we got. We tell OpenGL what kind of sampler to use for the texture. And it needs to track this so that way when we go to bind textures later, we can ensure that they are bound correctly. We can generate warnings if you try to bind the wrong kind of texture to the wrong kind of sampler slot. But yeah, and this will look different as well because we have to support more than just these two sampler types. All right, and then this is where we do the binding for the purposes of setting the data and the properties. So we use while OGL is texture slot in use is true, and we're checking whether the on deck texture slot is already in use. If it's not, we move on until we find one that is. Okay, texture slot plus plus. Then we confirm that the next sort of texture slot is less than the number of texture slots, so that we haven't exhausted our texture slots. If we have exhausted our texture slots, this is a case where we issue an error message, but we still bind a slot, so that way we can continue loading the texture, even though this will result in one of the textures looking incorrect for that frame. And we can move on from that. All right, so that's that. We bind the slot. So this logic here is good. This holds up. We've been using it successfully so far. And then we implement the slot tracking. We say that the current slot of the texture that was already in that slot is -1. Texture in slot and current slot texture in slot is dynamically sized array to be the size of the number of texture slots on the system. In my case, it's 32, but on other platforms, it might be 16 or 64. Most cases, it's 32, I think, on most graphics cards. And then we set it to -1 to indicate that the texture in that slot is not currently bound, or that texture is not currently bound. Then we mark it as in use by these. There's actually a variable that marks it as in use. Is texture slot in use, and we don't set that here because we want the ability to rebind this slot later during the same draw call, if this is executed during a draw call. Okay, and then this is where things need to split off. So all of this, switch min filter, switch mag filter, this belongs in these separate functions. So let me think about that. We'll probably want to reverse the order of some of this stuff. These properties don't need to get set before we send the texture data. We send the texture data first, and then we set the properties, I think. So let me cut these. Oh, and texture wrap modes. We need to have functions for those. So far, I've just been telling every texture to clamp to the edge. So like, if you take a look at Link when he's linearly interpolated, let me do his texture files. Let me do his texture file as linear again. And then open up the scene. At the very top, it clamps to the edge, so it doesn't wrap around at all, and that's fine. That works in some cases, but it also can work against you in some other cases. And a lot of times you're going to be wanting to clamp to edge, like for screen effects or whatever. But sometimes you want the wraparound to occur, and that's largely what you'll be doing on 3D models. You don't want to have harsh lines appear instead of wrapping around. Or like a texture, you want the edges of the texture to blend together very well when they're being sampled. Yeah, so that'll have to be its own thing. So this whole block I will cut. I'll leave that to do. And then down here we have the functions where we send out the buffer to the OpenGL. Hey, you wrote the rendering code yourself? Yes, I did. Yeah, this is all original. As original as OpenGL rendering code can be, because it's the number of ways you can make a renderer with OpenGL is a lot smaller than the number of ways you can do on DirectX or Vulkan. So 3D rendering, yeah, there's 3D. I mean, so it's kind of a mistake to think that way. It's just numbers. So I know you multiply the vertex positions with matrices. Yeah, it's exactly the same logic. In fact, a lot of times 2D games, when they always have billboard sprites or front-facing sprites, they'll still use the Z to do depth testing instead of sorting, which is maybe a bad practice. You should probably sort your sprites if you're doing 2D. But I know you multiply the vertex matrices positions with matrices, but what's been bugging me is just what data to put into the matrices. Oh, so like how do you construct a matrix to do a certain transformation? Is that what you mean? Here we go. Let me review this logic here. Like what parts of the matrix is what transformations? Yeah, that's a little tricky. I took a linear algebra course in college, and I didn't do very well in it, but I got enough of the concepts to kind of get a feel for what's happening. The whole point of a matrix transformation is that you're taking and applying in one operation, and I say one in air quotes. In one operation, you are taking and moving the coordinates of a vector into a new space. But you can, and I put it in quotes because you can take and break apart the matrix into individual calculations on each vector component, and they make sense separated. It's just that matrices make it a lot more straightforward. You construct the matrix, and then you can perform the math on a bunch of data at once, and it becomes a lot faster. But yeah, for that stuff, I'm actually not populating my own matrices. I used to. Prior to transitioning to GLM, I had my own math library I'd set up where I was saying construct me a perspective matrix, please. But those I basically got them off of Wikipedia. I think Wikipedia has a list of algorithms that you can use, so like stretching and so on and so forth. And it's not very often that I have to think about how these work, because a lot of times you just think about it as like I transform it this way first, and then that way first, and that way first, and then you multiply all those together, and then you get a single matrix that does them all. But sometimes it's useful to be able to rely on some property of the matrix to be able to do things, or to deduce things about how things work, like scaling only taking up a certain section of the matrix, or something like that. I think the easiest thing is relying on a friend who knows math. Yeah, that's even better. Actually, even better than that is actually like employing somebody that knows the math so that you don't have to. That would be the best thing, but not all of us are business owners. All right, so yeah, so let's make sure that the employing that costs money, it does. Yes, and that's an unfortunate truth is that you can't just start a business, no matter what the conservatives say. I'm in debt, I can't go around paying people. Yeah, exactly. I feel you there. Okay, so I feel like I probably just broke something in the order. So we got the slot binding here. We have a switch on the number of color components, which is deduced from the STBI load call. So is width and height, and is 16-bit. So actually, this all can happen independently of setting the properties. So that's good. I can just reorder that and it'll work. All right, so down here, instead of doing switch min filter, switch mag filter, I need to do, oops, stop. I need to do some function wrappers. So let's say set texture min filter, and we'll pass in the min filter. But we'll also need to pass in the texture handle. So let's do texture min filter. Texture should already have been defined up above through the generation function, and so on. And then let me think about this. We're going to need to have a separate min filter and mag filter. But when it comes to, I think I have nested in these calls stuff for setting up the map mode. Yeah, there we go. So in the minification filter, minification filters are where map modes come in. So map mapping is the process of pre-computing the smaller version of textures. It's like it's a convolution of the pixels around it, so that way when it looks smaller, the blurriness is more accurate than if you had sampled the higher resolution texture. It's a little complicated, but there's a link directly between minification filters and the map modes. So yeah, I'm thinking through this real quick. We have a switch inside of the min filter switch. Case min filter nearest. We have switch map mode and then break. So we set the min filter to be either nearest map nearest, or nearest map linear. And then for linear, we have linear map nearest, linear map linear, and GL linear for no maps. So I guess it would make sense to separate the map mode property from the minification filter. But it means that the most common use case for these functions, which is to load a texture, is gonna look a little strange, because all of these functions are going to be checking that texture is bound. And not just that, but the minification filter call and the map mode. Let me change the title of this. Map mode. Make these correct, so I'm looking at the right thing. The map mode will also have to take into account which minification filter has already been set. And if we change the minification filter, then we have to change the we have to know what the previously set map mode or minification filter was, and vice versa. If we change the minification filter after the texture's been loaded, we have to consider which map mode was selected. So that's good. It gets a little weird. Maybe it would be better to just do this all in one function. So we'll say set texture properties, and we would have the min filter, the mag filter, min filter, mag filter, and the map mode as parameters to it. And then that way the internal logic will it'll know what you're setting, basically. And there's not going to be a situation where you're going to need to set the minification mode and the map mode independently without already knowing what the other will be set to. So yeah, I like that. I like that quite a lot. So let's do this, set texture properties. This will be an internal function. I will go to textures.h up here. We'll have load texture implementation. Below that, we will have EP API void set texture properties, and then it will take the texture handle texture for text, and then these three properties as well. Bam. Okay. I think that's probably useful. Let's do an implementation of it now. So right above, actually right below this, down here, we'll do set texture properties. We don't need the export macro in the definition, and there we go. Now we can set the properties. I will cut the switches out of this. Switch mag filter, and also the wrap modes. We will set those up in the same call eventually. That's a detail I hadn't really thought too much about. We're gonna want to add a line inside of here that's like wrap mode, and then like clamp or so on and so forth. I forget all of the options that there are, but there's several clamp options that or wrap options that you might have. Yeah, all of that. Oh, and then the generation of mipmaps. We only want mipmaps generated if mipmap mode is not none. So all of this has to go. All right. So that would be all of this then. So this includes the minification filter and magnification filter, mipmap mode setting, the texture wrap mode, the generate mipmaps, the generation of mipmaps. That'll all Control X to take it out. Basically leaving this function to only do the generation of the texture, the passing of the image buffer to OpenGL, and then freeing that buffer and returning the texture handle. Okay, and I'll paste all of the stuff we just cut into the new function set texture properties. And give us a little space for comments. So the first thing to do is to bind texture. Because of the way that we do texture slot handling, we don't actually have to resubmit the bind request to OpenGL. When we do the texture slot, deduction up here, we have found a slot that's suitable for rebinding, and then we rebind it, and then we tell the OpenGL side of the engine, we tell it that the texture in that slot is now the one we just generated. So OpenGL, or I should say the engine already knows on the OpenGL layer that the texture we just created is currently bound. So the texture binding logic will skip calling GL bind texture again. But we still have to go through the hoops, because in the editor, when we call this, we are possibly changing the texture properties after it's been loaded, and it's not necessarily bound to a slot anymore. But it's only going to give you that efficiency drop in the case that it's not bound, if that makes sense. I don't know. Sometimes it feels like when I narrate what's going on in my head, it will only make sense to me. But we bind texture, and then we set the properties. Simple enough. So we will come back to that in a minute. Before I start setting the properties, I do actually need to make sure that this is invoked in the correct place. So I took this call completely out of the load texture implementation because I'm going to call it after load texture implementation is invoked. So that'll be down here. So that'll be set texture properties, texture, min filter, mag filter, and min map mode. Cool. And then the implementation call, then we will be getting rid of the extra parameters for it, and I'll need to do the same thing in the definition up here, like that, and then in the declaration in the header, that's the wrong one, here. So this will just take the path of the texture. Simple enough. What are you complaining about? Declaration cannot add. Okay, it's just IntelliSense taking forever again to come to its senses. Okay, I'm not detecting any errors inside of the load texture implementation, and that's good. That's not where I want to be working right now. Inside of the load texture call, where we go to do all this stuff, I'm now going to reorder events a little bit. So this is where we load the YAML stuff. We get the min filter node, map filter node, map node. Yeah, well, thanks for coming in, person. It's always good to have a little bit of company. Good luck with your projects. And I'll catch you later. All right, so we got the YAML parsing stuff here. I think this should all follow the load call. So we got the nodes, we check that the nodes are there and valid and stuff, and then we actually get the mode enum populated from that string, and then we do the texture loading. I'm going to Control X all of that. So what we have now is that we get the tree, we check that the tree is valid, we check that the path key is present and is valid, and then once we have those two things, we have enough data to load the texture. We do that here. If the texture doesn't load correctly for some reason, then it will return a null handle, in which case we will not do any of the other stuff we wanted to do. So I'll do if texture, and then do braces. Oh, and there's already an if texture thing going down here. So I'll just concatenate those blocks. Yeah, that looks good. Alt Shift F, and now we've got something that's looking a little bit more robust. So we load the YAML file, we confirm that it's got a texture path, and then we if the texture did load successfully, then we continue on. And that continues on to doing set properties, setting the properties from the properties parsed from the YAML file, and then set tracking. Here's where we will do tracking for, yeah. So set texture handles by path. We store the path of the texture, and the texture handle will be a key to look up its own path. And this is the path to the YAML asset file, which is good because it's a one file per one texture. Anyway, well, one file per one texture, one sampler type, I guess. So it could be an array, but it would bind to a single sampler. Good. And then we do the reference counting. Yeah. So, and set texture properties actually is not a potential point of failure, so we don't need to do any more hedging in this code. We just set texture properties, and then whatever comes out is what we got. Perfect. I think that is looking swell. So now it's just a matter of getting the set texture properties function working fine. Yeah, so the first thing to do is to make sure that the texture is bound. I'm going to basically copy and paste a little bit of code from the texture generation function. Which is here. Use the on-deck texture slot for loading. Basically, every draw call, we sort the list of texture slots by the use count of, or the use frequency of the texture in that slot. And that makes it so that when we rebind a texture, when we find that we have to use a texture that's not already bound, the first textures that we rebind are the ones that were least likely to remain bound anyway. There's a bunch of logic behind this that I might have to explain in a standalone video at some point, but for now, I'm just gonna accept that it works. Texture slot in use, good. We get the slot number, and then we get, all of this is to get the slot number. And once we have the slot number, GLint slot number, we call GL active texture and then bind it, and then we set the properties here. So I'm just going to copy all that. I don't encapsulate this in the function because there's an alternative form of there's alternative forms of this that I use in other locations, specifically the ones where you actually do want to mark the texture as in use. But for now, I will just copy and paste it. Okay, down here. And everything except for the texture term should be fine, because I use text for the parameter name instead of texture, which is the local variable scope name of the previous function. And then texture target. I don't know what the texture target is, so let's deduce that. I'm going to need to store the texture target, aren't I? So I keep around in the OpenGL layer, I keep around an association between the texture handle and the sampler that it needs. So that way I can confirm that the when you're binding a texture to a sampler slot, that it actually is compatible. However, I now need to know the texture target for the sake of being able to rebind that to that texture target. So my first question is, can I just deduce it from sampler needed for texture? Because if there's a one-to-one correlation, then I don't need to store both, and I can just deduce from the fact that GL sampler 2D is being used that it's a texture 2D. But I'm not really clear on that. Okay. Three categories based on the basic data type of the image format: floating point, signed integer, and unsigned integer. Okay. So that actually means that there's a 3-to-1 relationship here. If with the sampler type, it's entirely possible for I could use the floating point signed integer and unsigned integer versions of a sampler to associate with the texture type, which actually means that there's a direct conversion probably, because if I'm already storing the sampler type, I could probably always deduce what the texture type is. I'm not exactly sure where I would find this information. Okay. Maps. Sampler objects. All right. Okay. Sampler, blah, 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 blah. Process of using a texture, well, two halves. Texture objects are not directly associated with or attached to program objects. Instead, program samplers reference texture image unit indices. Whichever textures are bound to those image units at the time of rendering are used by the program. So the first step is to set the uniform for the sampler. Yeah, okay, that's fine. You know, this is not an easy thing for me to quickly look up, apparently. So I think it's probably just easier for me to say, to store the texture, texture target for the target type for the texture. So what I'm going to do is I'm going to go into the OpenGL side of things, and I will add an additional map. And instead of being sampler type needed for texture, it'll be target type of texture. And I'll need to expose this in the header as well. So OpenGL.h, right above where we have sampler type needed for texture, I will add extern association between the graphics texture handle this is not inside of the regular graphics namespace, so I don't think I can just do that. Can I? Is this good? I guess it is good. I'll try clearing out the graphics terms in a minute after I'm sure that this compiles. But yeah, target type of texture. So current slot, target type, sampler type needed. This could probably be renamed to like sampler type for texture, but I'll leave it. Good. And now that we have it, we can store it and then use it. I will need to at some point clear that map, but we'll worry about that in a minute. So instead of doing a local enum for this, right? Hang on a minute. The thing I'm getting stuck on right now is that I don't think we actually reset this at any point if the texture fails to work for some reason. Is there a point of failure available after we do the buffer allocation? Or after we do the loading of the PNG into the buffer? No, I guess not. So yeah, we can count on everything that we assign being valid from that point on. Okay, so instead of doing this, instead of doing the texture target variable, we will do OGL target type of texture at texture equals GL texture 1D. And then we can do the same thing for the variable below. And then this will be available for use later. But we do need to ensure that this gets cleaned up in the cleanup call. So we'll take a look at that in a minute. I'm just scrolling through to make sure I haven't missed something. Okay, so texture target's missing. We will now use OGL target type of texture at texture. These are hash maps, so these will. Well, hang on a second. Well, this isn't a hash map, but at some point I'll have to be reconsidering my stance on STD map in these. I'm not really at the point where I'm profiling my code yet, so these are all just STD maps. But yeah, this will either be fast, or we will replace it with a regular hash map that will be way faster. That's like order 1 instead of O log n. All right, texture target. Texture target's only used in a few more places. Actually, it's only used in that one place in the rest of the call. Perfect. Okay, so that seems to be good. Where do we reset the other tracker? Sampler type needed for texture. So in release texture, we do an erasure of sampler type needed for texture. So we can do that here. Texture, target type of texture, that erase. And then in cleanup textures, we do the cleanup. All right. Cool. That seems to be correct. That seems to be everything we need. So when we're flushing all the textures, when we go to reload a game module, for example, we will be clearing out that map outright, and we will be eliminating the key for a texture handle when the texture is unloaded. So yeah, I think that's good. I think that's it. Yeah, that's everything for that topic. Cool. So here we are. We've identified the on deck texture slot, the one that's least likely to be in use. So we can rebind it. Oh, hang on a minute. This should be wrapped. So we will only call this code if the texture's not already bound, but we'll worry about that in a minute. Let's fix the texture target binding code. So now we have target OGL target type of texture text, and this will give us the type of texture that we will be binding to it. If I am following my own logic correctly. Okay, yeah, there's one thing I messed up, and that is this is not a GLint type, this is a GLENU type. I think that internally they're the same, but I trust in GLAD to be able to distinguish when they aren't, because they may differ on certain platforms. And I also want the logic. I want the code to match what OpenGL docs says. So in here, target type, instead of doing a GL int type, we do GL enum. And we do the same thing for the definition up here. Target type of texture is now GL enum. Are you going to stop complaining? Good. All right. Awesome. Cool. All right, and that's that. So this is the correct way for us to bind the texture if it's not bound. But I'm going to put that in braces real quick because we have to do this in an if block. We'll say if that'd be OGL current slot of texture dot count, or actually no, we would be using current slot of texture at text it equals -1, I should say. So current slots are 0 through 31 in my case, but it's 0 through whatever your max index is on your computer. I use -1 to indicate that it's not bound to a slot. We could do current slot of texture. So if it's currently not bound, we do all of this. Else, actually, I'll do this as the else block, the binding code. The most common case would be that it would be already bound, so we'll do that if as the first case. So if it's greater than or equal to 0, meaning that it is currently bound to a slot, we will do we will set the active texture to be that slot. The point of this being that if it's already bound to a slot, we just will do the operation on the texture while it's in that slot. So we set the active texture, and then that active texture will be that texture slot will be operated on going forward for the rest of this. And I don't think I need to track. That's a good question. Let me take a look at all my calls to GL active texture. It just occurred to me that I don't track which slot is active. Usually, I just set the slot active when I go to operate on the slot, and I'm wondering whether that makes sense. So I do it right before it binds. What is this called? Bind texture. So slot number equals sorted texture slots, OGL next sorted texture slot. This code can actually all get replaced with a call to the OGL map that we just created. I'll make a note for myself real quick. forget the exact name. And then we bind the texture. So even though there's a bunch of code in between the active texture and the bind call, this is still a situation where we're about to bind the texture. Same thing goes for this guy. And then in cleanup textures, we use it one last time to make the 0th texture slot the active one, though there's not technically a crying need to do that. I think I mostly do it just in case dear I am GUI. No, there's no reason I can think of to do it. Any situation where you'd want to affect a texture, you would call GL active texture to make the texture slot that you want to operate on current. It just makes more sense to me that if you're doing like a total reset of your runtime, that you would start operating on texture slot 0. But I could technically get rid of that. Yeah. So this is actually the first case where I care about making a texture active, but instead of binding. No, I'm still going to bind. I'm still going to bind a texture before I set the properties on it. So that makes sense. That's good. So yeah, we'll do active texture, but it's already bound to that slot. So yeah, this is the only case I can think of where I would do GL active texture and not have to bind, because I'm not setting the active texture for the sake of binding another texture to it. I'm doing it to set a property. And this is the first time I've done that in my code. Cool. So that all makes sense. So far. Okay, and that's all well and good. And then we have to set the properties now. So we have a switch for the min filter and mag filter and so on and so forth. Texture target is now going to be looked up from that table. I'm going to go ahead and do a GL enum local variable called texture target and set it equal to OGL target type of texture for text. There we go. So you're only doing the lookup once. The lookup should be order of 1. Once I get my maps replaced, but I don't know. It might just make it a little bit cleaner to read the code, even in that case, to just have a separate stack variable. I'm starting to get more and more fond of doing this, where I take and I make a stack variable just for the sake of making the code easier to read. I used to be against that kind of a thing, because I was just like, why not just cut out the middleman and directly use the value inside of these things, or directly use the output of the calculation inside of these calls. But now I think it's a little bit nicer to be able to read this line and say, okay, yeah, we're binding the texture target, instead of like having to take the extra second or so to parse out, okay, we're looking up the type of texture for this texture. It's easier just to see texture target and that's it. Cool. So that's looking good. We currently don't have the other wrap modes set up. Mip-map generation. This is an interesting one. Because if we are enabling mip maps, we need to generate them. right now I'm not even doing that manually. I'm doing that through GL generate bitmap. I have a warning here to indicate when I'm not using a power of 2 texture with a bitmap mode. I could probably move this warning into let me cut that out. Move this warning into the load to texture call itself. But yeah, I don't know. Eventually, we're probably going to want to do add support for doing custom bitmaps, where you convolve the bitmaps yourself, or you use special effects. I forget who discovered it, but at some point, somebody who's emulating Paper Mario on the Nintendo 64, they had discovered like that Nintendo did a clever thing with bitmaps to make a certain floor look like otherworldly. They took like the top level texture was one color, and then each bitmap layer down of that same texture was a different color. So depending on how close it was to the camera, the texture would kind of change rainbow colors because of it, and that was done by setting up custom bitmap levels. And it's not uncommon to do your own bitmaps inside of big engines like Unreal Engine, but for now I think I'm just going to do bitmaps directly. The thing that I'm not so sure about is how you would delete bitmap levels from a texture. We'll have to look at that. But for now, let me move this warning code into this layer. Oh, I would have to move this into the layer above, wouldn't I? So set texture properties knows the texture, min filter, mag filter, bitmap mode. When we go to load the texture itself, this is the scope in which we know the width and the height of the texture. So I could store the width and the height of the texture inside of load texture implementation, or I could pass in whether as a parameter whether or not it's a power of 2 texture, or whether or not it's got bitmap modes, and we can do the warning inside of this code. I don't know, that's a little clunky. You know what? I'm going to add the ability to look up the width and the height of a texture after it's been loaded. That doesn't seem super useful up front to me, but I know that there's probably situations where in your code, like in a renderer code, like if you're doing like pixel art that has to be crisp and clean at like multiple zoom levels, what you might do is you might have an anti-aliasing algorithm based off of the width and the height of the texture. And because it's a renderer, it doesn't know the width and height of every texture because you're not necessarily going to use the same width and height for all your textures. So maybe this would be useful outside of just the internal scope. So let's do that. First, let me put the warning here. So right before we go to set the texture properties, let me format this. Right before we go to set the texture properties, we parse out the min filter, mag filter, and bitmap mode. Specifically, we'll know at this point what the bitmap mode is. So if the bitmap mode is not equal to none, then we will want to do the check on the power of 2 for the width and the height. So that'll happen here, right before we do texture properties. It could come after, but it doesn't, I don't know, it doesn't really matter to me. Graphics load texture, bitmaps generated for non-power 2 texture. So we'll need to store the width and the height now. And also I'll need to do I could either do this as a nested if, or I'll do it as a, I forget the exact term for this. Short circuit, that's the term I'm thinking of. We'll do a short circuit. That's a little awkward. Okay, let's do a nested if statement. Okay, nested if statement. If map mode is not equal to none, and then we check the width and the height for power 2 texture using this bit logic trick. So width and the height will need to be unsigned integers because we have to use this bitwise logic here. We take the width. Oh, hang on a minute. Yeah, that's a little. I guess if we're in this block of code, we've successfully loaded the texture, then the width and the height are guaranteed to be 1 or greater, so this logic will work. Okay. I think this will be the last thing I do before I take a quick break. I just need to find a place to store this data. So this is font data, font metrics used if you load up a font atlas. Texture reference count, texture handles by path, MSD of texture handles, path of texture handle. I guess it belongs here. So far, I haven't really been tracking anything interesting about the textures themselves, like, you know, how many components they have, or things like that. I've just been getting that data and storing it only long enough to pass it off to OpenGL. So I don't really have a section in this file for this yet. So I'll just make a new one. So this will be a map of the texture handle to the width and the height. I'll do an std pair for this. Unsigned int, unsigned int. And we'll say dimensions of texture. Seems good enough to me. So we'll have a width and a height. Maybe I should comment that. I suppose there's probably a GLM type for unsigned ints, isn't there? What would that be? GLM vec UI vec uvec2. So it would be type def of a vector, 2 of them, glm uint, glm packed high precision. Let me see what that looks like actually. Default precision. I basically only ever use the floating point stuff from GLM, but it might be a little bit clearer. You know what? No, I don't think it is. Instead of doing that, I'll do a width and height. Worry about it later. My style is to only use GLM stuff for actual graphics math. And I haven't really seen a reason to go away from that quite yet. Okay. Dimensions of texture. So now we've got that. I need to add cleanup code for this before I forget. So let's look for the cleanup code for texture reference count. So dimensions of texture dot clear, right where we do the texture reference count. And then right where we're going to do the erase, we do erase for the dimensions of texture as well. Okay. Good. Okay, that's good. Perfect. So now we've got a spot to store this stuff. When we go to load texture and we get the width and the height, at this point we have the width and the height. We can store it, but I'm gonna do that instead when we do the when we have the confirmation that the buffer was loaded correctly. That. I think that makes some sense. This is all the stuff related to the width and the height. We actually don't do anything else with it for the rest of this call. No, we do. We do check up here. So, yeah, whatever. All right, so now we've got the width and the height set. It's set when the texture's loaded, it's cleared when it's unloaded, and it's flushed when, or cleared when the cleanup method is invoked. Good, so now all of that, we can, after all of that, we now have access to it in here. So we'll do, I guess that'd be unsigned int width equals dimensions of texture. Or actually, I can do better than that. I can say auto width height equals dimensions of texture, and pass in the texture handle, which is called texture in this function. And this will use structured bindings to bind and make a value for width and height that I can use. Cool. Awesome. I might consider at this point making a getter for the width and the height, but for now, I'm actually going to leave this as just local tracking for textures.cpp. But in the future, if I'm writing a game and I find a situation where I want to have access to the width and the height of a texture, I will add an API call to textures.h, so that way we can retrieve this information. But for now, it's just internal only. Cool, and now we have the warning out here instead of inside of set texture properties. Perfect, okay, so I think we're pretty much there. I think we're almost there. let me look at the code again. So if the current slot of the texture is greater than or equal to 0, so not -1, then we will call GL active texture on that slot. Otherwise, we will identify an on-deck texture slot, make it active, and then bind the texture to it. Okay, and then from there we're free to operate on the item. Okay, so down here, texture target. We do the switch on the min filter, setting all these things depending on it, setting all these things depending on it. Yeah, and all this stuff looks totally fine. The only open question is about mipmaps. So far I've just been calling the generate mipmaps on the new texture and calling it a day. However, now I'm faced with the question of deleting mipmaps that have already been generated. Since there's no way to drop a mipmap level, I would say it's pretty fast process not to call an API. Okay, so apparently dropping mipmaps is not a thing. Let's check what this call does. So we'll go to docs.gl, very good resource for OpenGL references. Okay, so you can specify the target or the texture. There's a generate texture mipmap as well. That's interesting. GL generate mipmap and generate texture mipmap generates mipmaps for the specified texture object. For GL generate mipmap, the texture object that is the texture object is that bound to target. For okay, so I can actually call this instead and directly set the mipmaps, generate the mipmaps for the texture. For cube map and cube map array textures, the texture object must be cube complete or cube array complete, respectively. Yeah. Mipmap generation replaces texel image levels, L level base +1 through. What these dollar signs are about? Maybe there's something wrong with the port on this page, or maybe it means something else. Maybe it's supposed to be a code block. I don't know. Level underscore base +1 through Q with images derived from level base. Okay, so it kind of looks like anytime I call this function, it will replace the mipmaps that have already been generated with new ones. But yeah, it looks like there's not a way to keep the texture loaded and then just deallocate directly. Maybe that's not correct. Maybe that answer isn't accurate, because he was rather dismissive of the question. Because it is true that it doesn't really make a lot of sense for you to be dropping bitmaps at runtime in a game situation or in a working application situation. In my case, I care because I just want the thing to look accurate if you turn off bitmaps in the texture settings. Nobody seems to be asking the question for the same reasons that I am when I'm looking at the search results. There we go, bitmaps. Da-da-da. So what I could do is I could simply reload the texture if the bitmaps were already generated. That's not a huge ask for performance sake, because in most cases we're going to be invoking set texture properties immediately after creating a texture. It's going to be pretty much exclusively in the editor that we will be setting the texture properties independent of that. So I guess it would be totally fine for us to check whether the bitmaps were already created, and then simply reload the texture if that becomes necessary. But now we're kind of getting into like a awkward recursion situation. Let me think about this, because I don't want to be like trigger the whole sequence of events again if it doesn't have anything. It's not. I mean, it wouldn't really be recursion, because at worst it would be one level, because a newly generated texture won't have bitmaps. Oh, you know, I've had an interesting thought just now. I could probably just leave the bitmaps if we are changing the minification mode. Let me look up the minification filter parameter real quick, because here we go. Because if it might be easiest to say that we only generate or regenerate the bitmaps when it's not done, but we just leave them in place otherwise. And if we leave them in place, my main concern is that it looks correct inside of the editor if you turn off bitmaps and you want the bitmaps to appear like they're not in use. One of these probably would ignore it. So nearest and linear returns the value of the texture element that's nearest to the center of the blah 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 in Manhattan distance. Manhattan distance being where pi is equal to the square root of 2, I think, or something like that. I can't come up with rubric. It's taxi block matrix, where it's like instead of going straight to a coordinate, you go x and y units vertically and horizontally. Or pi is equal to 4. That's what I was thinking of. The distance from the center to the corner of the unit circle is the square root of 2 in Manhattan distance. Alright. Chooses the bitmap that closely matches the size of the pixel and uses the GL nearest criterion. Okay, so this tells me that if I'm using GL nearest and GL linear, then it doesn't actually care about the bitmaps. It just uses the base texture value. So this is all good. When we are changing the properties of an existing texture, that texture will still have bitmaps if it had bitmaps before. But when you turn off bitmaps, they will no longer be in use. So they will appear correct inside of the editor. And then in the shipping game, of course, you're not going to be changing these on the fly. So it'll just automatically allocate the memory in the most correct way. It's not allocating and then deleting things, if that makes sense. All this logic doesn't even apply when you're not in the editor. So perfect. I think that's it. I think we've got everything forked off correctly. That was a lot of work for essentially an organizational change, but this change will make it a lot easier in the editor for us to be able to change properties on the fly, and that's the whole goal. All right, we got a compilation error somewhere. Use of undeclared identifier slot number. Where is that? Here. Okay, so slot number. Oh, I don't know why IntelliSense didn't do red squiggles on that to begin with. I was calling GL active texture on slot number instead of the current slot of texture. Let me do that. Yeah. Yeah. IntelliSense should have squiggled at me as soon as I pasted that, but it didn't. Okay, what now? Too many arguments in the function call. Oh, once again, I have to update the this guy. Okay, and then F7. Though that brings up an interesting point. Now that we've got the separation of concerns from loading the texture to setting its properties, I will have to set any properties I want on textures used in the editor. I will have to set those manually. All right, that compiled. F5 time. Okay, and something's immediately broken. These textures are not looking correct. Maybe I have to set the properties for them first, but let's try to open up a scene. Go to scenes, open up a basic scene. Okay, so the textures inside of the scene load up correctly. It's just that they don't display correctly inside of the editor. I wonder why that would be. The primary difference is that we haven't called any code on the icons yet. We haven't set up their properties. Let's try that and see what happens. EP graphics, set texture properties, pass in the folder texture handle. We'll do texture filter linear for both of these, for both the min and the mag filter. And then in the bitmap mode, we will set to nearest. We'll do the same thing for the file. Okay. Let's see what happens. Okay, so that fixed these icons. Though I was frankly not expecting it to break in the first place. So let me review this function. I wonder if there's something critical going on in here that I need to move out of the function. Okay, all of this is just to bind the right slot. And we get the texture target. Min and mag filters. And then we generate bitmaps. Yeah, literally all we're doing is we're setting properties in here. Maybe that's a OpenGL thing that I wasn't aware of because I've never tried to do it before, but maybe the texture doesn't actually work at all until you set certain properties. Let's take a look at the OpenGL site. Texture completeness. A texture object has a concept of completeness. Complete texture is one in which the logical state is used for operations. Until the texture is complete, it cannot be used in shader sampling or image load store operations, and attaching an image from a texture to a frame buffer object requires completeness. It's complete if it fulfills the following three kinds. Bitmap completeness essentially requires that there is consistency between the image formats of the allocated bitmap levels. The texture parameters, okay. So before we set the properties, we haven't generated bitmaps, so that's not a problem, I don't think. Cube map completeness, image format completeness. We're not doing a cube map. The internal format of a texture can also affect its completeness depending on its sampling parameters. Integer color formats and stencil index formats do not support linear filtering. Okay. Sampler object's completeness. When using a texture with a sampler object, the completeness of that texture will be based on the sampler object's sampling parameters, rather than internal sampling parameters of the texture. For example, if it only has a base bitmap and the bitmap range parameters permit accessing beyond the base level. What's that mean? Texture base level, texture max level, integer values. Okay. The texture will be incomplete, or if the GL texture min filter parameters require access to bitmaps other than the base level. However, if you pair this object with a sampler whose min filter is GL linear or GL nearest, then the texture image unit will be bitmap complete. So we haven't set its min and mag filter. Maybe that's a requirement. I'm curious if I was to comment out these again. I wonder what would happen if I made the icons way bigger. 256. Yeah, these are 256 by 256, I believe, these icons. Let me double check that. Editor, content, icons. How big is it? Doesn't even say in the preview. And I don't have the ability to select properties in here, so let's go to Show in File Explorer. Yeah, 256 by 256. So this is full size. So it's not just that it's trying to use a bitmap and it doesn't have one. Okay. So yeah, I guess you have to set the properties at least once. That's news to me. But it's okay. It doesn't really mean we have to change anything in our code. It just means that if I forget to set the texture properties for a texture inside of the editor, then it just won't work. And that's kind of that's fine. That comes with the territory. I think we're pretty much done with that separations of concern thing. We're probably ready to move on to adding more properties to the texture asset files. But first, I want to follow up on a stray thought that I had. And that stray thought was that these textures might be getting loaded more than once now. Originally, I was having everything reset with the reloading of the project. So let's go to runtime.cpp inside of the editor. So this is where we create the editor window and context, and we create the engine runtime. We do all the command line option things. And then when we go to run, we do all this. And then we have a thing called create and destroy engine runtime. The thing that I'm concerned about is that I think I had it set up before where I was reloading a texture each time we closed down the project. And if that's the case, then every time we close the project and open up another, every time we close the project and it flushes the runtime, it would load another texture. And we would have a memory leak, basically. Small one, but yeah, every time we close and open up a project, it would add another instance of the texture to the engine. So yeah, I'm going to run a little experiment. Let's go to the window code. This will be the last thing I do before my first break, the 2-hour mark. Our window 132, 132 on the editor side. And then I want to turn on double buffered because I'm gonna run this through RenderDoc, and RenderDoc does not work correctly with OpenGL unless you're double buffering for God knows what reason. But yeah, we'll load the enterprise editor, working directory, and the project and all that stuff looks good. Launch it. So here's the enterprise editor again. I'm gonna try a few things. I'm gonna try closing the project. Oh, that's interesting. Is there a problem with closing the project? Oh. Current path is empty. The icon table is trying to load up a content directory, but it's not available. I'm actually okay with this bug, because it's not strictly speaking a bug. It is an issue that occurs because I haven't implemented the feature that will cover it up. When you go to close a project in Enterprise, My intention is for it to not try and display the content view. It's to get rid of everything and then show like a splash where you can pick a different project. So the entire scene editor closes in the final version of this, thereby bypassing this issue. I'm wondering if I could, or if I should, resolve this just for the sake of doing what I wanted to do. My intention was to use RenderDoc to capture the inputs to rendering the content browser after I've closed and opened the project several times, because I wanted to know whether the texture IDs were incrementing. I guess I'll have to resolve it. So current path is the path that not the current working directory, but the current directory viewed in the content browser. That is empty because we're trying to display. Hang on a second. Which folder are we trying to display? Probably the contents folder. Yeah, so by default we have the content browser open. So the content dir path is not getting a valid value when we go to leave. Actually, it'd be more correct, it has a valid value, it's just that it's an empty string. So on Windows, when you're running the Enterprise Editor, the working directory is the install location. So let me think that through. So normally when you're running it and it's not redirecting the content folder, it will just be running from the location that the file is in. So that should be an empty path, but because it's literally empty, we're getting an error from the file system API. You know what? I'm just not going to deal with this right now. That's fine with me. Eventually, we will need to worry about that kind of a thing, but I think I will just catch the issue if and when it occurs, rather than trying to spend a bunch of time fixing things that don't need fixing for the sake of tracking down an issue that hasn't peeked its ugly head yet. Just gotta save myself a little bit of time to keep myself a little bit saner. So let me turn that double buffering back off because I don't need it. That's the wrong one. Window 132. 132. Oh, my backspace button got screwed up. Okay, that was weird. Window 132 for the editor. And turn double buffering back off. F7. And then we'll move on. Okay. Awesome. So we're pretty much back on track. We've got we did all the laborious work of separating the concerns of the setting the properties of textures from creating the textures. So now when we go to load these textures, they are created and then their properties are set after the fact. So these are examples of that. In the editor, we are manually loading the texture instead of letting the Enterprise all-in-one call do it. And then we are manually setting the map modes and things after, and these are coming out fine. Now that we've done that, we have a foothold with which we can start adding and changing properties. And then when we get the inspector set up to handle these asset files, which we'll probably want to do soon, probably before we even get to the materials, the material system's use of them, then we will be able to change the properties of the textures on the fly and see those effects inside of a preview. Probably not directly in the scene, because that'll involve detecting and updating. No, it would affect the scene. We have the handle for the texture that's already been loaded. We never load it more than once. We set its properties to change. Yeah, so what we can do is we can literally have a scene that has a texture, find the texture that it uses, and then change its properties and see its effects in the game scene, which is, yeah, that totally works. For now, I'm going to take a quick little break. I'm doing this for a little over 2 hours. I'll be back in like probably 10 minutes, and then we will start adding properties to the textures that we can do fun and cool things with. I'll be back in just a minute, or just 10 minutes. Alrighty, where were we? Cool. Yep, I muted my mic. Cool, so we are back. Prior to taking a break, we did a couple of really important things. First, we fixed a rather annoying bug involving opening up scenes, and this was an issue not with the texture system itself, but an issue with how we handled a failure to load specific sprite components, which has now been fixed. We can now fail to load a scene or fail to load a sprite and then successfully unload the scene later. Cool. And then we got the separation of concerns done with the textures.cp, with the loading of the texture from the setting of the texture properties. And that's going to be critical as we implement the ability to change that stuff from the editor. Yeah, and then let me open up a text file. Right, and we have a scheme started for setting up properties inside of here. So let's do what we were doing before. I'm going to uncomment a few things. And we're going to talk about what properties we want to make available here. I'm pretty comfortable with this layout, where we do a sequence of paths for the files. If we have more than one, then it'll be usable in an array. An array or a 3D texture, I suppose I should say. And then we have slices for taking and breaking that down. I think I've got a Word document where I started making this list. Yeah, there we go. So we have, we support these kinds of texture assets. 1D, 2D, 3D, cube, and then an array of 1D, 2D, and cube. So slices apply to most of these. I'm having to think a little bit harder about that. If we utilize more than one path, and if we utilize more than one slice, or if we utilize slices in general, I should say, then what we are doing is producing something that is not just one image. It must be an array or a 3D type. Though I suppose it could also be a cube map type. So if you do a cube map, there's multiple ways that you can specify a cube map. If you do an equirectangular projection, that's the like the 360 camera thing that you see on Facebook, where it's like wide and it's like fish-eyed, the whole thing. Then we will convert that automatically into a cube. It gets trickier than that, doesn't it? Now I'm thinking about it, because we know that when you specify a cube map, that that if it's all in one image file, then it'll come in one of 3 aspect ratios. Technically one of 2, but one is rotated. If it's 2 by 1, then we can infer that it's an equirectangular projection, because that's the ratio that they all have. The left to right is a 360 degree view, and then the top to the bottom is a 180 degree view, and so that's 2 to 1. It's always the way it's going to be. For regular cube maps, you're going to have 4 for the 4 sides of the cube, and then you'll have that T shape. So it'll be a 4 by 3, and if you do it a different direction, then it'll be another 4 by 3. Though I suppose you could also have 3 by 2 if you want to split it up that way. Huh. Yeah, so I guess that's where it gets a little confusing, because we also have to consider doing cube maps from other vantage points. Let's take a look at cube map possibilities. I'll open up Unity real quick, because I think that they have a nice visual to go along with this. Maybe I can find one on Wikipedia, because there's a bunch of different ways to arrange these faces in a cube map. Hey Owen, welcome. Hi Michael, how are you? How are you so dedicated to your project? You never seem to lack focus. I always lack focus. I think being in front of a camera forces me to focus, and that's one of the big perks about it. I tend to be productive when I have someone watching me. that's the brain trick I'm pulling when I go to work live. But yeah, it's I have a terrible time focusing, especially when I'm offline. It takes a great effort for me to focus. I would like to see a total list of all the ways that you can arrange a map. And if I'm remembering correctly, the Unity, which is still loading, still importing all the default standard assets. Unity has a really nice visual menu for letting you pick your projection. Okay, here we got something. So this is equiprojection. Okay, but this is not giving us an absolute view. Huh. Are you still loading Unity? Oh my god. Takes 10 years to load up one of these things. Maybe there's something inside of the manual on this. Okay, here we go. So this is an arrangement of kinds of cube maps. They didn't use multi-threading for the mass loading. Yeah, you know, I'm sure they probably did, but yeah, I get where you're coming from. Let me take a look at that at the Unity editor not responding. Yeah, I'm not really seeing. Oops. Huh. Yeah, I don't know. Is it actually frozen? No, it's still got the animation going. Okay. Yeah, it's just taking for freaking ever. Anyway, so there's a whole bunch of different ways that we can go about this. Okay, it's finally loaded. Okay, let me find a skybox, and I think I've got some maps here. So this is a 6-sided one. So this one, if we go to edit, file show code. Oh, this is a material. It's not a texture. Okay. So let's find one. This is a free set of skyboxes that come from the Unity store. Where do I get the? I just want to see the raw texture. Okay, here we go. Default cube. So if I was to open this up in an external editor, oh, what? That's weird. It's an HDR file and it opened up in RenderDoc of all things. Let me open that up in something else. Show and Explorer. Why is it? Do I have another program I can open this with? I'm sure I can open it with Paint.net. I don't know how well it will do. HDR is the high dynamic range stuff. Oh, okay, so yeah, you can't open high dynamic range in Paint.net. Never tried to do that before. What can I... Let's find one that's not HDR. How about that? I'm getting really annoyed. All I want to do is I want to see how it selects the mapping. Okay, so we can pick between 6 frames, latitude, longitude, and mirrored ball. Mirrored ball, I'm not really sure what that's supposed to be. I think that might be proprietary or something like that. So it's really just picking between those 3 options. You don't have... Vertical cross layouts as well as column and row of cube map faces are supported. Lat long, sphere map. So this is what a sphere map looks like, apparently. It's literally just half the reflection. That's a little weird. Okay, and then you can also do it out of 6 separate textures. So I guess we should make a list of all the things that we can do with cube maps. And we won't be able to implement them all today, specifically because with latitude, longitude, lat long, which is one that I want to support, but the equirectangular projection will actually require a considerable amount of math, because we're going to take and have to resample the image into something that resembles a cube map. One program I liked was the map editor of Neverwinter Nights. I could do 80% of the job without any coding knowledge back in 2000, 2005. That's great. I've never played that. But yeah, having robust level editors is really awesome, especially for like games that like really benefit from user content. I was a huge fan of Star Edit in the original StarCraft. I haven't played the new StarCraft, but I wonder if they have a map editor in the new StarCraft. It was it made the game so great to play online. Was people coming up with like really cool things, and people would come up with like their own campaign missions and things too. It was really awesome. Yeah. Okay, so I guess we'll have to make a list. I'll do a new file. We're having to think about all this stuff up front because considering all the possibilities, coming up with the most generalized way to serialize that data is valuable. I don't want to be doubling down on one format if it becomes hard to extend or hard to use in a bunch of situations. So cube map projections, we've got T-shapes. So these would be, all of these would be 3x4 or 4x3. Because it's going to be the top, middle, and bottom, and the 4 sides. Just going to take a peek back at this. So we could have it 4x3 or 3x4. I probably will need to enforce one way or the other. So that is, I would want to always have plus y be on top and negative y be on bottom, for example. So it's not true that I would want to have every single arrangement of the T-shape be viable. Interestingly, this arrangement here, the plus y is still on top. I was thinking that like they would just like rotate this on its side or something like that, but no. What happens is the view that's behind you is flipped upside down and placed on the bottom of the map. That's what it looks like to me. They also have these interesting layouts here, where it's just a row of squares, which I guess could make some sense, but it wouldn't be really useful in the editor. I don't know why you would export a cube map this way. It's a strange one to do, because like with the T-shapes, and the reason why the T-shapes are popular is because like you can see how the faces flow together for the most part. There's a continuous run of pixels from the long end to the short to the short end, the top to the bottom of the cross. Whereas in these, it's literally just broken up. The opposite sides connected to top, opposite sides, and yeah. So I think we'll probably have to reinforce. Let's enforce just a single arrangement of the cube map. Realistically, folks who are working in the engine will be using the equirectangular anyway, and equirectangular is great because it kind of resolves all these problems. You have a continuous flow of pixels across the entire space, so you can more easily see what that looks like. See what connects to what, and you can also like touch it up in photo editors really easily. But if you bring in a T-shape, I think we'll have to do a proprietary split. So there's not really an easy way to generalize these shapes. So we'll have to do a cross shape. This will be for sure 4x3. We're not going to do 3x4. I don't think. I don't see how this vertical cross shape is better than the horizontal cross shape, and I don't see why on Earth you would do this with the straight column and straight row. So we'll say a 4x3 cross shape. Supported. And then we'll do an equi-rectangular projection, which is going to be a 2-to-1 ratio. So in Enterprise, the editor, we can deduce which of these should be used based on the size. And then we'll have multiple images, which each image will be 1x1. So a square for each side, and that's in OpenGL land when you're going to be doing a cube map sampler. That's the way that you have to do it. The API doesn't give you the ability to like say, here's my equi-rectangular, make a cube map out of it, please. And you can get around that by like just bringing it in as a regular 2D texture, and then using an algorithm to map using polar coordinates. So you would take and like get a direction vector pointing towards the pixel that you want inside of the box, just like you would for a 3D texture, and then you just convert that into polar coordinates. But it would get rid of some of the benefits of having a all-in-one cube map texture, which is that you just have the sampler do that for you instead of having to put it in your shader code. Would you be able to use your engine to use voxel Minecraft-like games? Yeah, for sure. I'm taking great pains, and probably the only reason why this thing is taking so long is that I'm taking great pains to make sure that this is as general purpose as you can get. My intention is to make it more general purpose than Unity or Unreal. Like, I don't even prescribe a rendering pipeline. And like in Unity, which Unity is really flexible, and like they have the scriptable rendering pipeline now, which is great. But like you have to abide by their rules when it comes to sorting things. The only things that I want to be prescribed by my engine are things that are truly universal. And that's making it kind of grueling to think hard about things that I want like how I want the APIs to work out for the textures. Just coming to the realization that I would need texture asset files took a long time for me. I wanted it to just be import the PNG and that's it. Okay, so cross shape, equi-rectangular projection, and then 6 by images. Now, how would slices come into this? Slicing. The thing that I'm thinking of when I look at this is specifically sprite sheets and like arrays of textures from a single image, and 3D textures, which it's the same thing. Basically, you would just take a bunch of different slices of a 3D space, and you would make that into a single 3D texture. But yeah, I don't think that this makes it really easy to work with on cube maps. You could argue that you would have cube maps, like multiple cube maps within a single texture. I just don't see that happening. Cube arrays will probably just be multiple files, because again, the value of a cube map is that you can like when you're like working with the raw asset file, the value is that you can actually see where things connect. Let me find that site that we were looking at before. Polyhaven, I think. Yeah, Polyhaven has some HDRIs that you can use in all kinds of places. But like, if you're working inside of and all of these are equirectangular projections. I'll grab an interior space just because it makes it really crystal clear where things connect. But like, if you're working with these assets raw, like imagine like putting this like in a sheet with multiple, like why would you do that? Just make them separate PNGs. So yeah, I think I'm gonna say that cube maps will not support slicing. So I had been assembling this list of how you can create a texture type from the images that you bring in. Cube maps. Well, we can do a cube map array from multiple images only. I think that'll simplify things quite a bit. And so each image in the cube map can either be the cross shape or the equirectangular projection. Oh, but then we have the situation where we do the 1x1s, where we bring in each image individually. I think that's something that I do want to add support for. So we can do a cube map from one image. What's up with the spacing there? Okay. And we can do a cube map from multiple images. So this would be the 1x1 size. So each of these would create one, and each of these would create multiples. So let's list all the combinations. I'm just getting this all out on paper so that I can think about all these possibilities while I am looking at the texture asset file as we come up with the spec. So with cube map arrays, we could have, I guess we would just say oops, didn't mean to hit that. We would just say like n cross textures or n rectangular projections. So you would have an array of maps that are the same kind. Or you would have n divided by 6 separate images. Or actually, that would be n times 6. So n being the number, being the count of elements in the cube map array. Okay. So slicing really just doesn't have a home here for cube maps. 3D and 2D arrays should support slicing. So I guess slicing, let's head back to this guy. Thinking through what we've deduced. Slicing, this slices thing, should only apply when you are using 1D, 2D, or 3D textures. But even in those situations, we have to come up with better things. So I'm going to flip this on its head. I'm going to do this a different way. We're going to list the things we can do with one image and things we can do with multiple images. And we will go from there. So with one image, we can do a 1D texture. We can do a 2D texture. We can't No, we can do a 3D texture with slicing. Okay, 3D slices. Because then we can like split it up like a sprite sheet. And then we can do a cube map. And then actually that's the end of the list. No, it's not. We can do a 1D texture array from slices. So if we have a regular 2D image, we can take and strip every single row or every single column and make those 1D textures. How about 2D texture arrays? Yeah, so 2D texture arrays. If we take a sprite sheet, that's one image, we slice it up, we get an array. 3D we can accomplish with slices only. Cube maps, I'll go ahead and put the details in here that this would be a box map or equirectangular. Then that's the whole list of things we can do with one image. If we provide multiple images, we cannot do a 1D texture, because like what would you do? You would concatenate them into a same row. I mean, that would be silly. 1D texture array. Yeah, we could do a 1D texture array. It would be multiple 1D images. You could make a argument that doing a 1D texture array from multiple images would be possible even with slicing. Because you could have like one image that's like a buffer of gradients, and then another image that's another buffer of gradients, and you could put them all into the same 1D texture array for quick use later, even though you're going to separate them into different assets. I don't know why on earth you would do that, but hey, we're making a general purpose game engine, so support slicing by concatenating array. Yeah. Okay. And then with 2D, you can't make a single 2D texture with multiple images, but you can do a 2D texture array. Making a brain activity, I smell. Hey Jolo, welcome in. Yeah, we've made some significant progress with the with textures in the engine. So textures now, they're all inside of EP text files, and those can now specify properties. Fucking annoyed you are. What's fucking annoying you, Jolo? Yeah, we can do a 2D texture array that supports slicing from concatenation as well. Valorant? Oh. Yep. I had one of my high school friends who was a roommate for a while. He had a real problem with first-person shooters where he would play for very long periods of time, and then he would start to suck because he was starting to get tired. And then like he would just get like livid mad because of how badly matches went, and he's the kind of person to throw controllers around the place. Do you have similar issues? The path to frustration. Frustration leads to anger. Anger leads to hate. Hate leads to the dark side. Oh, I was doing Darth Sidious, but that was Yoda, wasn't it? Yeah, basically. Gotta pace yourself with multiplayer games. Yoda, indeed I am. Okay. Yeah. So if back to what I was doing, I'm ensuring that I've got throw controller. I do not. Yeah. There's I'm ensuring that I have every possibility covered for the uses of slices and multiple images, because that's going to define how I make my texture arrange. Can't continue the Yoda speech. Yeah, it's hard to keep up. You know, there's several places in Star Wars. I heard about this recently, that somebody had noticed that there's actually a ton of places in Star Wars where Yoda just talks like a normal person, and nobody remembers it. Where he puts all the words in the right order, and it's kind of weird to see those in isolation. But yeah, making sure that I've got all my bases covered. So 2D texture arrays can be created with multiple images, with multiple 2D images, and then if you add slicing to it, it'll just add more images to the array. So how about 2D textures? 2D textures are not possible. 3D. How about 3D? So we'll say multiple 2D images. I got to the point where I just want to rake up. Yep. It's a good way to keep you going, but unfortunately, a lot of developers use that want for ranking up and getting prestige and points to trap you into a system where you're not having fun anymore. There's a concept called Skinner boxes. I don't know if you've heard of that, but a Skinner box is like a bait and switch. They like say, come and have fun, and then they give you goals like ranking up and whatever, and then you're playing just to meet those goals, and you're not having fun anymore. I don't care how much I will have to pay, but I want to rank up. Oh man, they got you. That's how you get got. Yeah, with 3D textures. Play. Oh, okay, gotcha. Play. Yeah, that's better. But yeah, that's a thing that's a line I very rarely cross, is spending money on free to play stuff. Anyway, 3D textures. So multiple 2D images. You provide multiple images; they will stack up and make layers of the texture. We can support slicing as well. In this case, we'd be concatenating depth to it. Okay. And then there's the cube map. And this is where we cover what we were talking about before. So cube maps can be assembled from multiple 1x1 images. So for every cube map, you'd have 6 sides. So 1x1 images times 6. Put that in there. that's the only scenario actually. We are not going to support multiple. That's actually the only situation where a regular cube map, not a cube map array, but just a cube map, would allow multiple images. Because by definition, the other file types would be just one image. So, okay. How about cube map arrays? So you could theoretically do a cube map array from slicing up a file containing multiple box maps or equirectangular maps. But I will not allow that. I think that's not very helpful. I like Valorant because it's a challenging online multiplayer, but I got to the point where it's no longer challenging my team. But my teammates are not good enough. Like, I will rank up, but how long is it going to take? Yeah, it's annoying. It's easy to get stuck in that loop forever. The last first-person shooter game I played a huge amount online of was Destiny. And they're still going strong, but I realized it was just like putting me in a place where it was just taking so much of my time, and I was doing things. There were other things I could be doing with that time that would be more fun, other games to play, books to read, and things like that. So I just kind of stopped at some point. And here I am making a game engine. One of the things that I'm doing while I'm not playing Destiny. So cube map arrays will be possible through a variety of means. We could do sets of 6 1x1 images. Or sets of box equirectangular maps. Or yeah, rectangular. I'll just put it at that. So I either have to improve a lot to hard carry the team or play more. Yeah, that's rough. But yeah, so for a cube map array, then we can provide sets of 6 1x1 images. So if we have 12 images, then we can do the first 6 as 1, and then the second 6 as the second, and going forward. Or we can do sets of the other projection types. Importantly, none of this involves slicing. Cube maps do not involve slicing. I'm going to colorize that. So I decided to try to improve a lot because that'll help me in the future. Yeah. That is a good way to look at it. One of the, like, I don't know if you've ever played competitive Rocket League, but the folks that are really, really good at Rocket League, they mod the game to provide their own training courses, and then they spend a whole lot of time practicing specific niche trick shots, and they take it really seriously. It takes, in order to be very, very, very good at a game pro level, you have to practice a lot. It's like sports. I'm going to highlight the things that use slices. So with one image, you can produce, we'll say, I'll put a key down here, bold, and I'll make this regular font color. Bold supports, uses slicing. Yeah, I saw some videos, yeah. It's pretty crazy. I've been pretty good at Rocket League, but there's a certain point where you have to make a massive leap in how good you play in order to be able to rank up over those folks. Okay, Now, reorganizing this way with the things that you can do with one image, multiple images, and how those support slicing has made this actually a lot clearer to me, what we're doing. I'm just going to quickly confirm that I haven't overlooked something. Got cube map arrays, cube maps, 3D, 2D array. Okay, so the slices thing is going to be totally optional. And more importantly than that, we have to have a special parameter specifically for cube maps. So that tells us quite a bit about what we need to do in the design of the YAML file. My plan is to take a break from Valorant and then play AIM Labs and Valorant consistently. Yep. Yeah, sometimes taking a break is helpful. The first time I played Hollow Knight, and Hollow Knight's a very difficult game when you get into the hardest challenges. Like the first time I played it, it took me like so long to get through, and like I was starting to really kind of like get burnt out at the end and not do very well. But then I picked it up again, and then all of a sudden I was doing a million times better, even though it had been months and months and months since I had last played it. Okay, so, all right, so I think I've got an inkling of a design, and I'm going to start doing that now. I also bought CSGO Prime as an alternative for when I don't feel like Valorant. Yeah, I haven't played any CSGO, but I know that it's amazing that it's been going so long and people still love it. Like it's been a very long-lived game. All right, I'm gonna need to come up with a name set for these kinds of projections. I wonder how Unity calls them. So they got 2D, cube, 2D array, whatever. Where's the mapping? So we've got 6 frames layout, latitude, longitude layout. They call it cubic environment, cylindrical is what they call it. Though the latitude, longitude layout, I'm surprised that they don't just say equirectangular, because that's the correct name, and that's that's what it's called, and it's shorter than what they put. But yeah, whatever. So I'll say equirectangular. 6 frames, and then I don't know, T something. A friend of mine played Hollow Knight for the first time and then took only about 2 hours to beat it. The whole thing. I mean, like I suppose that there's a shorter route where you just beat the Hollow Knight, but still. Oh yeah, of course I've heard of Godot. Godot is a really popular engine, and it does a lot of stuff that I like actually. I think I have high hopes that it'll improve and then supplant Unity for the indie development scene. But I'm still making my own engine. Yeah. So what we'll call it is we've got equirectangular, and I'll start listing these in the comments. Equirectangular, cubic. What does cubic mean? Is cubic the T-shape, or is cubic the... I guess I'll do the T-shape. Yeah, I looked into it, started using it. Yeah, try it. And let me know what you think. I know that it... the folks who enjoy it the most, they use the Godot script, like, to do everything. They have a proprietary language for doing gameplay code and stuff like that. But it's like, from what I understand, like everybody who's used Godot script casts that as an advantage. It's like a well-featured language that you can do anything in, and it plays really nicely with the rest of the engine, which is very important. So I'd be really interested to see how you enjoy it. Yeah, I haven't tried it myself, so I don't have any thoughts about how it accomplishes things. I just know like the bare minimum about it. Okay, so here's the options I think I'm going to provide. Slices and projection are going to be optional. When you are doing a texture type that supports slices or projection, it will utilize those. Slices will be columns, rows, and count. Basically the same way we do with the sprite sheet. Say, hey, have this many elements width-wise, this many elements height-wise, and I want you to do the first X of them. Oh, but I should also say direction as well, or something like this. To say whether or not you're going row by row or column by column. Actually, it'd be column major or row major is what I would say. I haven't tried it yet either, but it seems kind of like OBS, but as a game engine. That's an interesting way to put it, because I know what you're talking about. It has OBS vibes. I have a suspicion that they're both built on Qt. I'm actually gonna Google that real quick. Because I'm wondering if Qt is that really popular GUI library for C++. And I happen to know OBS uses it. Okay, no, so yeah, that's just OBS. Yeah, it's kind of like if you like look at a screenshot, like the way that it's laid out and stuff, it really does feel like OBS. Maybe that's just a style thing or something, but yeah, it looks like it's a really solid engine, and I have high hopes for it. I wouldn't say that it's mainstream enough where people should start learning it for their resume. That's not a thing yet. But for doing your own projects, yeah, totally. I would say that you should do that. There's a term for column major and row major order, column major order are methods. Oh, is there not a term for this? Okay, I was trying to think of like if there was a term that I could use for direction instead. I guess I could say order. Ordering, order. Let's do order. And this would be row major or column major. Basically, the idea is that you're determining whether or not, like, which way you're going first inside of a split thing. So this is everything you need to slice up an image. How many columns, rows, and items, and row major or column major. And then this is everything you need for projections in QMaps, and these will be optional per this list. Awesome. UI5 seems too unintuitive and Unity too complicated to set up. So Google some alternatives if I'm Godot. Yeah, Unity, I think Unity makes a lot more sense if you are already familiar with like low-level engine stuff. What I do enjoy about UE5 is that, like, as an artist, like, if you're taught how to, move the camera around and place things in the scene and whatever, like, as a level designer, it's fantastic. It's just got great tools for building up scenes really quickly. And for building up like terrain and things like that. It's just really powerful tools. But it's like a tool that's intentionally made for the artists, and it's not very intuitive how you get your code to work in there if you're not currently taking a course on how to use Unreal with C++. Though I will say that it's a lot more approachable now with blueprints than it ever has been. Visual programming in C++, like visual programming in Unreal Engine is quite good. Blueprints make it really easy for you to hack things together. And you can even make an entire game without even touching C++. And I think that's its saving grace right now. But I have an opinion that you should be making it as easy as possible to program things with code. I think programming is the primary game development tool, not editors and not visual programming. But yeah, Unity's problems right now are mostly with their company. less to do with how the engine actually performs, and more to do with the fact that their business daddies are incorrigible. Okay, so I really got to focus on this. Sorry, Jolo. So we know that only some of these types will be supported by slices and projection. So let's make a list of them, and I'll do this in comments. So 1D array, 2D array, and 3D support this. 1D, 2D, 3D. And that's it. We don't do cube, we don't do cube array. And we don't do 1D, 2D, 3D. Okay, that makes sense. And then with the projection, and I'm gonna move this above. I'll move these above the elements that we are working with. This will be supported by cube and cube array only. So for everything else, which would be 1D, 2D, 3D, sorry, 1D, 2D, oh, that's it. So 1D and 2D then will skip both of these. We'll skip slices and projection. Okay, that makes sense. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 7. Okay, that accounts for everything. Okay, I think I'm pretty happy with this. I might come up with a better name for slices later, but that's okay. That's unimportant right now. Oh wait, no, I still have to consider how to best organize the paths. Okay, hang on. You know what's so fascinating? Text-to-image AIs? Yeah, oh man, that stuff is really cool. Have you been playing around with the one that's on Discord? I forget the name off the top of my head. It's like everybody gets a free number of submissions to make to it. You can come up with some really cool stuff. I had come up with some really fun stuff. Go to creative. Hang on a second. Midjourney, that's the one. Yeah. I'm trying to find the. I can't remember where I put it, but yeah. Yeah, you can come up with some really crazy things. There's certain areas where it's like not so good at parsing your words or understanding it, but it's like it can come up with things that are just entirely unexpected and inspiring. And it's a thing now where artists will take and submit requests to Midjourney, and then those will come back and they say, hey, that looks really good, and they'll like plug it into Photoshop, and then they'll make something new with it as a base. Okay, so the last thing to consider is multiple files. So multiple files is only supported by a handful of these types. Let me do a list. So 1D array, 2D array, 3D cube maps, and cube array is what we called it. So I think though what I'll do is I'll just make this, I'll leave this as a sequence. And only use multiple. I'll leave this as a sequence. So that is a list of files. But in the case of 1D, 2D, second. All the others will only use the first element. Okay. A base Midjourney image won an art competition, but it only got revealed after the winner was nominated. That's fascinating. Yeah, the world's going to be really different. In some ways, this is also happening in gaming with the NVIDIA upscaling technology. You know, where you plug in the game, you play a game, and then the NVIDIA will automatically upscale the textures and make them look like sharper. Like, it's using AI to do that. It's using convolutional neural networks, just like Midjourney is using. And like putting like that and like deepfake technology on top of 3D rendered graphics is like, it's been forwarded as a potential way to do like hyper realistic game graphics in the future. Because it's a way for you to do, you can do like a cheaply rendered 3D scene, and then the AI will fill in the details easier than it would take to actually render them. That was a huge debate about if he won because he didn't make it. Yeah, that's fun. That's a fun legal concern. I remember that there was a similar court case involving a selfie that a monkey took with a photographer's camera, and literally the court said, no, you don't own this. He took the picture himself. And so it became public domain because animals don't have ownership rights, but the photographer didn't take the picture himself, so he couldn't be credited with it. Interesting area of copyright law. Okay, so I think we're set. I think I've got the things I want out of this list. So now we've got a format. Let me put that on the side, and we'll keep that open. And then we'll want to start including these. So currently, the current setup that we have ignores slices and projection. I just put those in there. It only cares about min, mag, and bitmap mode. It also ignores type. And it currently takes path as a single scalar value. So the first thing that I'll change is I will make paths be a sequence list inside of the code. And then for now, we'll just test that using a single value. And then we will start adding support for additional types. And it's going to be a little bit hacky to figure this out because I don't have a renderer that takes advantage of these types yet. So we'll have to kind of hard code hard code some stuff to test out in the renderer these features, and we may even step away from doing it in the editor for a little bit and just do it with the standalone game. The only thing humans can do better than machines is creative art. Now we can't even do that better. Now we can do better is, yeah. It's every little thing you can imagine a person doing can totally be automated. Everything. It's just that we haven't figured out how to automate it yet, if we haven't already automated it. All right, sorry, I gotta focus. I'm getting really. I've been mulling this over for 30 minutes or so instead of typing. Okay, so this is where we do the loading. I need to go to the functions below that. Here. So this is the new load texture function. This is where we actually do the YAML parsing. And this is where we do the YAML code. I think I'm actually starting to get more comfortable with the rapid YAML library, more familiar with how things are supposed to work. I've learned since yesterday that we can use parse in place with std strings. There's a couple of functions provided, toSubstring and toCSubstring, to let you convert to the types that our YAML uses. And then parse in place lets you just pass in a buffer. So it's totally fine to make an std string, load it with your YAML source, and then parse it in place, and then get a tree from it. And that's all in one line. And that's pretty nice. But yeah, so we get the tree. We confirm that the root node is a map. We then confirm that the path node is present. And this is where things are going to have to change a little bit. So for starters, it's not path anymore. It's paths with an S, even though I pronounced it like it was a Z. And then we check to see that it's key value pair. That's fine. We also need to know that it is a sequence. So we'll say if it's not a key value pair, or if it's not dot val. Wait. Do I have to do? What does isval do? I'm gonna have to do some more homework on this. No proprietary. Oh, it's whether or not this node is a val. No, it's we want it to be a key value pair, and we want the value. Val is. I guess I'll have to get the val from the dot val, and then is sequence, or is. Whoops. Sometimes I accidentally press Control-0 and that changes my zoom. Let's look up how this works on the site. Okay. So let's go to the quick start sample. And then let's look for sequence. Wait, is it called a sequence? Maybe it's called something else. I thought it was called a sequence. It is. I still don't know how you remember what your past you wrote. Yeah, it's less about remembering what I wrote. It's more about remembering what it did, what the goal was, what it was supposed to do. But yeah, sometimes I can't even do that. Okay, so tree is sequence. Okay. Check tree is map root ID. Check tree is sequence bar ID. So you pass in a node or an ID, and then you can say is sequence. Every time I open up my node, my code, I read through everything. Yep. Yeah, it's at a certain point though, it's going to be too much code for you to just read. You'll have to kind of know where things are located, and basically like memorize like the index, like make an index in your head of where everything goes instead of just looking for each individual thing. I need a child from the path node. I was thinking that I would get it from val. So val returns... Oh, val returns the string itself, not the node. Okay, that's important to know. So if it's a key value pair, and then I pass in... Oh, this is annoying. Just want to... I'm getting... Part of my frustration here is that I'm getting used to a new YAML API. And I don't like learning things while I'm trying to do things. But I do quite like this library. Yeah, sure thing, Joel. Thanks for popping in. Have a good sleep. Okay, so I'm going to find every... Thanks. Yes, I will. Bye-bye. I'm going to find every place where we use is sequence in the quick start and identify Oh, wait a minute. Okay, so let's take a look at this example. Foo and bar are keys. Bar is a sequence. Bar's value is a sequence. So actually, I do .isSequence not on the value, but on the node. Okay, that's a key insight. So that's what I was missing. So we have the path node. We check if it's a key value. Instead, I need to be checking whether it's a sequence. So path node .is sequence. Okay, so these probably are compatible checks. Actually, we only have to check this one. We check is sequence, and then that'll, because the path node comes up with the key, then when we use a sequence, we're checking up whether that node is a sequence. If it's an invalid node, then it probably will say false anyway. Okay. So we'll change this so I'll just say path node is invalid because this failure can occur if it's missing or if it's not a sequence. So we'll say it's invalid, and yeah. All right, and then we got the texture handle loaded from the path node.val.string. What we did is we constructed a string view. I'm not really sure that I like that, but that's what we have for now. Instead of doing it from the value directly, though, we have to get the first sequence in it. And so I'll I guess we'll have to do, yeah. So it'll be like index lookup. So braces, square braces 0 would be how I get that. So instead of doing val.string, I would say path node 0, and then .val.string. And for the moment, I'm just implementing the sequence container here. So after I know how to do paths, I will then switch to doing conditionalized path lookup based on the type that we provide. I think that makes sense. So this should work, except for I need to set my other texture files to use this same style. So it'll be paths, and then, oops, I need to do YAML. There we go. Whoop. What's up with you? There we go. It was doing the four spaces for tabs for some reason. Anyway, paths, and this is the first element of that, and we'll do the same thing for text 3.mptext. We'll do paths and a sequence of 1. Okay. Let's build it and confirm that it didn't break anything. Okay, so everything seems to be loading still. I'm playing in standalone and not in the editor, just to make it a little bit faster to test. But yeah, that seems to be loading fine. And then just to be extra sure that I'm on the right track, I'm going to add a second element to these paths. I will scramble around which textures they use. And then run again. Oh wait, and then instead of doing a lookup on the 0th element, I'll do a lookup on the first. And so that should change which sprites are what. And that'll confirm that I'm using sequences correctly. Yep, and now Link's on the left and Madeline's on the right. And yeah, perfect. All right, so now we've kind of got started on using sequences. Let's start implementing an API by which we can do other kinds of textures. Yeah, so I'll start with implementing the API, and then we will simply implement it for 2D. 2D and 1D textures, I guess. No, 2D textures first. Because right now the renderer that we're using only supports 2D textures and 2D samplers, and I need to be able to test this stuff out on a whole bunch of other sampler types. So we'll need to do some test rendering code where we're hacking together the use of cube maps and things. Not really sure how I would directly test 3D textures, but I don't know. We'll come up with something. Maybe I can find a volumetric explosion asset online and then use it as a 3D texture and render a voxel thing. we'll come back to that. Okay, so I'm going to close out of all these. Even this one, but I'm going to copy the elements out. Alright, so a little cat's hanging in the corner of the VS Code pass. Alright. So when we go to load the texture itself, so far we've only been taking in the path of the texture. We'll need to add the other elements that are present inside of the text file. So we're going to need to have it accept the type and the slices and the projection. The other things count as properties. Oh, and wrap mode is going to be a property as well. So like these things are going to be things that you can change after the fact. Changing the slices, the projection, or the other, the path or the type, that's going to be something that requires reallocating, reloading the texture in graphics card memory. So we'll do those things inside of load texture, and we'll do the rest inside of set texture properties or attributes or whatever I called it. Yeah, so this will take the path. We'll need to take. Oh, it's actually more complicated than taking the path, isn't it? Oh, okay. Let me think about this. So load texture implementation so far has been taking a single path for a single texture. We need this to take any paths necessary for this to work. So what we could do is we could take an initializer list, maybe. Of std string view. And then we will use either the first or the first several, depending on the type. So we'll have paths. We'll need to have a type, which means we'll need to have an enumeration to specify that type. And this is a exported function, so we'll need to go to the internal header and add it there. So we'll do enum class texture type. Yeah, I guess that's a thing. Part of me wonders whether we have specified something like that in the public API. I guess not, because prior to doing all this work, what we were doing was calling a separate function for loading each different kind of texture, and that's what's changing. So yeah, for now I'll just do an enum class that's inside of the internal header for this. So enum class, texture type, and then this will be the list of things that we had in the list of things that we had inside of the texture asset file. So we'll have 1D, 2D. Wait, is this right? Semicolons? Why is it complaining at me? It's supposed to be comma separated. So what's up with you? Are you Oh, because these begin with numbers. Okay, numbers. You can't start identifiers with a number. Otherwise, it'll treat them as numerical literals. So I guess I'll have to do something else. I could do 1D, 2D, or I could do they do underscore. Underscores, though, kind of give you the impression that this is being named for internal use, to be like a more private version of a public thing, and that's not the case here. So instead of doing underscores, I could just do like text, texture 1D, texture type equals texture type : I guess underscores makes the most sense right now. I'll worry about better names later on, but we'll start with the underscores on these. As weird as that is. Come on, stop complaining, IntelliSense. Okay, so we've got 1D, 2D, 3D, cube, 1D array, 2D array, and cube array. So this type now can be accepted here. I'm gonna. Well, I need to do initializer list includes. Which is part of. Oh, it's part of initializer list. Okay. So up here we'll do include initializer list, and then here we can do std initializer list of type std string view paths. And now we can do texture type type, and then type paths slices and projection is important. And this is an internal use function, so I'm actually okay with having a whole bunch of parameters. I'll want to do any enum for projections as well. And those will be I guess I'll do split, cube, and equirectangular in that order. And then we'll do int rows, int columns, and count for splitting. I think that makes sense. Okay. And then back in the CPP file, we'll use those as the parameters instead. And now we've got more to do. I'm going to need to do string to texture type, string to cube map projection helper functions. So I will just copy what I did up here. Basically, when I need to parse out the type from the file and the other stuff, I would be basically just calling the helper function to do the string comparison for me. That's what I did up here. And the interesting part about these is that I'm actually using the C4 C substring type because that's what you get back from RapidYAML. Oh, I don't need to do EP graphics like that anymore. That's an extra qualifier that I can get rid of. Sometimes when you copy and paste a whole bunch of stuff from one file to another, you forget to do things like this. Okay, better. Alt Shift F. Okay, back to where I was. So this will be returning a, what was it? I've got texture type and then cube map projection. Okay. All right, and then do so texture type, it's going to be cube map projection. Say string to cube, do the whole thing, cube map projection. All right, and then let's start simplifying these. Basically, we just do if statements. If string equals whatever literal, then do the thing. So in the case of texture types, the types we support are these. Copy. Paste. All right, so we will do if string equals that, and then if string equals that, and so on. And I'll set this up in a way that's not so hard to duplicate and edit. Okay. Load texture blank is not a and then we'll return. I'll treat. I might want to add a none or an error type for texture type for the sake of returning a null value. I'll come back to that when we actually start using these. But yeah, so I've got a simple function set up here, and now I will add an element to this if-else block for each one of these. So there's 7 types, 1, 2, 3, 4, 5, 6, 7. So we got 2D, we got 3D, we got cube, we've got 1D array, 2D array, and cube array. And these correspond to 1D, 2D, 3D, cube, and then we got 1D array, 2D array, and cube array. Okay. Good. And then we'll do something similar for this guy. Okay. Except for we're doing projections, which we only have 3 of those. And those are split, cube, and rectangular. Okay. And I'll name these similar things inside of this. So you got split, cube, equirectangular. All right. Okay. And then the defaults I'll pass out for now will be no split. No equirectangular, because that's going to be the most common single file type. Okay, so we got the helper functions in place for the conversion. That's good. What's going on down here? Oh, right, so we have multiple paths now. So we'll come back to that. Let's take a look at the YAML parsing stuff, because that's what actually sets this code up, and it'll inform the changes that we make. Okay, so we got the YAML source, got the tree, we've got the path node, we confirm that it's a sequence, and then let me think about that. We actually need to parse something else instead as our first thing. So we'll do our YAML node. I think it's like node ref. Yeah, node ref. This will be the type node. And I'll set that equal to tree type. So this will be the key. And then we need to confirm that it is a key value pair. So we'll say if path node or type node dot is key val is false. Then we will say error type node is invalid, and then pass the texture out and so on, and then we return 0, not having created the texture. Okay, and then from here we can do what we actually care about, which is to get the value out. So we'll say we'll get the texture type equal, or texture type. Is type already in use? No, it's not. Type equals string to texture type, and we pass in type node dot val like so. And this takes out the value as a string, but it comes out as a C substring, which is basically a string view into the string buffer, and the function we have above makes perfect use of that. It uses the correct type, and it converts from that C subbuffer type. All right, cool. So now we've got the type, and then we have to do a switch on the type. Do we have to do a switch? Yes, we do. We have to do a switch on the type. So we'll do switch, and pass in type, and then we have to insert all the types. And this is where I kind of wish I had Visual Studio to help me, but it's not here. So we'll have to make do. We'll copy out all the types that we need to catch, and we will paste them and get rid of the commas. Oops. Like that. And then we will do case texture type : thing : and then we have code, and then we have break, and yeah, And we handle each of these differently. Then we have the default, which is, I'll go ahead and do EP assert no entry, but it's possible that we'll want to have a separate type for that, for issues when we parse out. Actually, yeah, this would be a situation where we need to have an invalid type. So let's do that. Let's go to texture type. We'll add another one, but I'll add it up to the top. I'll add in null. And I'll do the same thing for cube map projection because we'll probably need one there as well. And then when we invoke string texture type, we'll return null instead of some other default. They do the same thing here. Right? Is that good? Oh, null is not legal because it's it's used as a macro. So I'll just say none. Okay, and then back to where we were. We can have a case texture type. None. And then for here, we would say, we would issue a warning. EP error, graphics low texture, type value is invalid. I pass in the texture, and then I would pass in the type. Okay, and then we'll do path, and then we do type. Actually, no, we would do type node.val. Except for I want to make that. No, I think that should be fine. I think the I think there's a no-stream operator on the C substring type, so that should be able to print. And if it doesn't, then that's on SPD logs conscious anyway. So, all right. So how do we handle each specific type? So, well, for 1D array, 2D array, 3D cube, all of these that we have listed here, we could use multiple paths. Otherwise, we just use a single path. I tell you what, though, that doesn't actually matter here. Maybe, hang on a minute. Yeah, we can actually do this a little bit easier. What I can do is I can just do an error check on the none value. Or if it's, we'll do it like that, because none is a value of 0. Oh, but it's strongly typed, so I have to do it. I have to do it this way. Regular enums, I can do it the first way, but not this, not enum classes. So this would be none. So if type equals none, then we'll do that error, and then we do return 0. And then we have the type to pass into the implementation function up above. That's the important takeaway here. Cool, so we've got the type. Then we do the node check for the paths, and then we need to get the path from it. So before we were just going straight into the load texture implementation. Now we're going to need to construct a list to pass in to the load texture implementation. I have it taking an initializer list. However, it's becoming clear to me that I should be using a vector instead. So we'll go to the internal textures.h, change this to a vector of string view. And you know what? It's occurring to me that I haven't included several other things in here. And I was trusting in implicit includes for this to work. So I need a vector, string view, and that's it. Okay. Good. Save, and then down in textures.h, save textures.cpp. Where were we? Yeah. So texture implementation now takes std vector of string view paths. Yeah, and then down here where we were coding, we can do a stack allocated constructor or stack allocated vector here. Since it'd be std vector of type std string view. Yeah, std string view. Yeah. And this will be the paths to load. Cool. And then inside of the path node, we just need to get all the values out and put them into here. So we've already confirmed that it's a sequence. So we just need to iterate through it. And I'm going to quickly look at the quick start to see how that's supposed to be done. Iterating through keys. So I guess it would be bar with the square braces would be how you index directly in. It's actually not very easy to find something inside of the quick start. Even though it covers most everything that you need to use this API for. So I'm just gonna use IntelliSense and have it see if it can tell me what I can do. We'll do path node dot size maybe, or sequence count. How about children? Num children, maybe? That might be a way to do it. It's num underscore children. See, the frustrating thing is that I'm seeing that you can plug in integral keys, but I'm not seeing at all. Not seeing at all that you can get the maximum number of keys. I just need to know how many are in the sequence, and I'm not seeing confirmation of that. Hey, Olan, welcome in. Yeah, we get people pop in periodically. Not very often, but every so often. How are you doing today? I should say, how are you doing this afternoon? Since I saw you earlier. Okay, here we go. Maybe this is something. Number of nodes in the tree, num children root, num siblings. So, maybe there's something in the FAQ about this. Doing fine, just met with my doctor and he reduced my meds by half. I might get back some brain juice to code. Nice. Some of the meds you take make it harder to focus. Okay, this is not an answer to my question, but this is maybe a clue to the answer. So this is where you're adding stuff to you're emitting YAML, basically. Root bar dot num children equals 2. Then they use these square braces to add values to it. And then they call num children and it's 4. So by doing that, they added children. And of course, bar unless they changed the source. I don't think they did. Bar was a sequence. Where's the frickin' buffer? Is it the one at the very top? Yeah, so bar is a sequence. Okay, so num of children applies here. So we would do, to iterate through the sequence, we would say for int I equals 0, and then I is less than node path node num children, and then I++. And then we can index into path node with I. Okay, so paths dot in place back. We would in place back a string view constructed from the C substring type. So it'd be path node I dot val dot string path node I dot val dot len for length. Does that work? Oh right, because this is in place, I don't do curly braces. Perfect, okay. So I'm having to assume that this is correct because it's not even the frickin' API doesn't tell me whether it's correct. I don't have an example of iterating through a sequence for God knows what reason, but here we can iterate through the sequences. I'll probably find some way offline to be able to do like range-based for loops or something as I poke through its API, but whatever. I got like 25 stream channel followed, but you're the most interesting. Some brain puzzles, good for the brain. Oh, thank you. Yeah, I have a couple of folks that like I know that play games on stream, and so like I tend to watch them. But then I've got a couple of folks that I don't know that are really good at game dev or coding or art or something, and then I watch them. But yeah, there's not a huge amount of folks working on game engines on Twitch. It tends to be folks that are working with Godot or with Unity or sometimes Unreal I've seen. Okay, so we've got the paths now. So now when we go to use the implementation, we pass in paths, and then we can pass in... Is this by const reference? It's not. It should be. Let's do that. And then do the same thing on the header. Okay. And then we need to pass in the types, right? Type, which we had parsed out already. And we need the cube map projection. Okay. Okay, I think we're making progress. So the code that we used for getting the type out, I will duplicate. And then we will get the other things we care about. So type is required, paths is required. Projection is not required, actually. Neither is slices. So what we'll do then is we will here. So right above where we were going to do the projection, I'll start labeling these with comments because little bit easier on the eyes. And actually, because these are not required, projection and slices are not required, I will put them below where we get the paths. Okay, and then okay, I think I'm getting this straight in my head now. Okay, organization-wise. So type and paths are required. I check those first. Providing an error and returning if there's a problem. And then we parse out the type using the conversion helper, and then we get all of the paths out of the sequence. Good. So now we're on to optional stuff. So the projection will come from here. Its code is actually very similar to the type parsing, except for it's not required. So if it's, what I'll do is I'll say if the type is valid, if it's a key val pair, then I will do the parsing, which looks like this. And this is going to be projection node. And this will be string to cube map projection. And I'll need to declare the type up above. Equals none. We'll default to none on the projection matrix, or on the projection. I just said projection matrix because it rolls off the tongue. The projection, cube map projection style. Actually, we can handle this a little bit differently because we already know the type, and we're only able to use this on cube and cube array. So what we could do is we could wrap this whole thing. Let me do that. I still have to present a variable to the implementation, so I'll declare it up here and set it to none by default. But I'll do if type equals texture types cube or cube array, like so, then we will go through this trouble where we get the projection node, confirm that it's key value pair. If it's not, we'll say that the projection node is invalid. Yeah, the projection node is invalid. And because this is a cube map, we will actually return 0 if it's bad. Because if we don't have a valid... No, you know what? We're not going to return 0. We're going to set it to some default one. I'm going to put a to-do note in here. Say deduce type. Deduce type from aspect ratio, which we can do now because earlier today we started storing the texture widths and heights for later lookup. But for now, I'll just say that projection equals map projection. No, I'll return 0 because I don't want to have to guess and then get it wrong. It would just look really weird. Essentially, without actually deducing the type from the aspect ratio of the file, we can't have any reasonable certainty that we will guess the correct type. So we'll say deduce type from aspect ratio and set it instead of returning. All right. Otherwise, we set the projection to be whatever the cast is. We get the value from the projection node, and we convert it to the cube map projection type. Good. Okay, so now we've got the... Let me look this over. We've got the type. We've got the paths. These are required things. And then if it's a cube type, cube map type, so cube or cube array, then we will get the projection node and convert it into the correct type. Oh, but then this can return none as well. So if it does return none, then we will want to return as well. If projection equals cube map projection none, return 0. And in this case, actually in this case I can bring this up into the upper if block, because this logic only applies here. And then we can issue a warning as well. And that will be path, and then projection mode dot val. Okay. Okay. Now we got protection against incorrect values and invalid nodes. Perfect. All right. Now the last bit is slices. Technically slices doesn't have to be its own block. I could just do something like this. However, I think this is maybe a little bit more clear, at least visually. So we'll do that. So slices applies only with 1D array, 2D array, and 3D. So we will do more if statements. Somehow I wind up with a duplicate of the type deduction. Okay, and then down here we will do slices, and this would be 1D array. Just copy it from here. Copy 1D array, 2D array, 3D only. All right, and then we'll do if. We'll do the same thing as before. We'll redo the. We check the what the type is, and so on and so forth. If type equals 1D array or 2D array. Or 3D, then we will do the parsing logic for it. All right, good. We'll need to have the variables up above to pass through, so we'll do columns, so int columns equals 0, int rows equals 5, or equals 0, sorry. Columns and rows should be 1 and 1 by default. What should they be? And then we'll do int count equals 1. So by default, it's just one big image. And then we'll have to do orders as well. For this, I'll just do a Boolean. Bool is row major equals. Do I want it to be row major first, or I do. I want it to be row major, so it'll be row major, meaning that if you're looking at a sprite sheet and you're considering the order that they are going to be sliced up and put into an array, it'll go 1, 2, 3, 4, 5 over the top, and then the second row, then the third row. So column minor, row major. Good. And then inside of here, we will do the deduction. So I haven't so far had to do conversions to integer types from YAML using this library. I wonder if they have support for that in here. Deserializing. Okay, that's helpful. They have a shift operator overload. See serialization examples below. Oh, this is for outputting to a nested string type. Okay. Okay, I'm starting to get used to this. So I can do an int type and then do a shift into it, and that should take care of it. We just need to get the correct nodes. Right. So we need to get the node for these slices. And that'll be from tree slices, like that. And then we'll need to do a check if slices node dot is key val. Wait. is map. Because it's got these. Then we're good. Else, we'll have to do default stuff. So we'll say unlike projections, we can actually continue to just use these default values without any additional information. So, like in this case up here, we have if we have an invalid projection node, I have to actually just abort because I don't know what what projection to use. But in this case, if we have a failure to read the slices block, we can probably continue to move on, not by aborting the creation of the texture, but by loading just the first slice, so the whole thing in one texture. So we'll do an EP error, graphics load texture. Man, I'm almost up to 5 hours. Hopefully I'll be done with this soon. And then I'll move on to other things with my day. Graphics load texture, slices node. And then we'll pass out the path to the texture file. And yeah, we don't return here. We don't need to set the default either because it's already at the default. We just move on. But if we've confirmed that the slices node is a map, we now need to get the values out of it. So we'll say if slices node columns dot is key val, I think I might be misunderstanding what is key val does. I'm starting to think harder about that. Because when I was using key val before, I was interpreting the key val to mean that is it a key value pair? But now it kind of seems like every node is a key value pair. Wait, no, it might not be, because it might just be a value in a sequence which doesn't have keys. Okay, so that's fine. Is key val is the validity check for this. If is key val, then we will output slices node columns, shift that into the columns variable, and then else EP error should these be warnings? Warn, EP warn. I mean, we can recover from this, but yeah, if we can't successfully parse out, if we don't have a key value pair for columns, then it's probably an error. No, I'm gonna just issue this as a warning, because it might just mean that like there was a merge conflict or something like that that wasn't resolved successfully. Yeah, so we'll say graphics load texture. and then do the same thing here. That should probably be in a block though, because now it doesn't fit on a single line, which means that there should be a block to match. Okay. That's looking good. Now you just copy and paste this a few times. So we'll do rows the same way. And then count. Okay. And then the last one would be is row major. This one is simple enough that I'm just going to do the check internally and not do a helper function, because there's only two possible values. So we'll say, well, let me do a little bit of spacing, work on these. We'll say if slices node order dot is key val, then we will do some deduction. I'll just get the else block right out of the way. We'll say order subnode is invalid, and we'll set slices node order dot val. That'll give us the C substring, which is a constant substring basically. So we'll do C4 colon C substring order stir equals, and then we'll do a comparison with that. We'll say if order stir equals row major, then we'll say is row major equals true, else is row major equals false. Actually, I need to do else if order stir equals column major, like that. And then I can do an else catch-all and say the value is invalid. And then pass in the value to the log. And I'll call that a sub value to make it a little bit more clear. All right, cool. I think that's it. I think that's us with all of the sliced data correct. Yeah, so just like all parsers, this winds up being a significant amount of code, but what we've done is pretty simple. We've just parsed out the projection data, the slice data, and we've done all the safety checks to make sure that they are all valid, and we do that conditionally based on the type that we provide up above. So I think that's all the data we need to pass to the implementation. Projection is the variable with the cube map projection. Then we got rows, columns, and count. that. Okay. Yeah, and all of this is set to either defaults or set to the thing that we parsed from the texture. So that's looking good. Now it's just a matter of confirming that this compiles and that we're getting the data we expect out of it. The actual implementation function should be broken right now here, because we haven't set it up to anticipate having multiple paths or more than one type. So before we call if file exists and all of that, you know what? Let's leave everything the same. And instead of doing if file exists on path, we will do we will just index into we'll use index 0 into path. So I'll shift select this whole thing, restrict my search to the block I selected. I'll find every example of path matching case and whole word, and I'll replace it with paths 0. And then that will get us the first string view in that vector. Okay, replace all inside that block. And theoretically, this would compile and work just fine. So I'll give it a shot. So the first sign of trouble would be if something breaks. So far, we haven't actually added behavior yet. We haven't changed the way that we load the texture, but that should be fairly straightforward to do now that we've got the data. I just need to confirm that it runs, and once it does, I'm going to set a breakpoint inside of the implementation file and then inspect the parameters I get back to confirm that they are looking fine. Okay, what do we got here? Got a problem. Use of overloaded operator is ambiguous. So this is inside of OStream. This has to do with... Oh, this has to do with some of the warnings that I've set up. Hang on a moment. So inside of this code, I passed in a couple of cases where I did a EP warning or an EP error with the variable, the C substring type. That needs to be as a string. So let's do our YAML to cars, I believe, or to... I forget how you're supposed to convert back. There's a way for you to convert from the C substring type, and I just can't remember what it is. Maybe it's in C4. Oh, that's frustrating. What I'll do is I'll just do, wait, can I do dot, what do we get out of this? Const car pointer. Const car pointer is probably fine, actually, for what I need. I think that the SPD log will accept const car pointers as parameters. Again, I'm going to be getting rid of SPD log, so my focus here is just to make it compile, not necessarily to... Not necessarily to make it work, because I'll be getting helpful enough information from the stuff that doesn't display. Okay, projection.val.stir and order stir.stir. Okay, let's try that. Okay, more problems. Doesn't look like it's the same ones though. Too few arguments to function call. Oh, right. Okay, so this is because we're directly using the implementation inside of the editor. However, we have to provide more things here. So we need to provide the texture type. So texture type. Oh, and I need to bring those into our namespace. Let's do that. So we got texture type, and we've got cube map projection. All right, and then inside of these functions, we'll need to start passing some of these types. So the type is going to be 2D. Texture type 2D, and cube map projection is going to be none. And then one row, one column, one count. It's possible that we'll want to have default. If I wind up using low texture implementation a lot in the editor, we may want to add default arguments to these, but for now I'm not going to do that. Still more stuff. Okay, error reference to type const std vector of std string view could not bind to an L value of type const car 20. Passing in the, oh, right, okay. I'm passing in the raw string. This actually has to be a vector of string views. So that gets a little fuzzy-wuzzy. So what I do is I'll put those in braces, and that should be enough to construct a vector of string views from that one string, literal. Okay, that compiled. Let's run it. Okay, we are missing some of our sprites. Debug console, let's take a look at what it says. Could not deserialize sprite component data for entity 1256. Oh, I know what the problem is. I've updated how this works in text2.eptext, but the other textures for Madeline and Hollow Knight, they are not updated yet. So this is actually correct. Close that. Okay, and what I'll do for now, I'm just gonna copy and paste the whole thing. And then and then tweak the path that we use. Okay, try that again. Okay, cool. So everything's loading, and that's actually the bare minimum of what I needed. So after doing all of that programming, everything's working the same, but the key difference is that now we should have access to all the data that we set up inside of text3 in the implementation function. And that's key because when we do the implementation function, we want to be able to use that to create alternative texture types that we can bind to different kinds of samplers. So now that we've got this function working, now I need to go into textures.cpp. Well, you know, I should run the editor real quick to make sure that the file and folder icons are loading, and yeah, they are. Okay. So we'll go back to the launcher version of the game. And in the loading function, the implementation function, I'm going to set a breakpoint now. And for each texture that goes to load, we're going to inspect what we get back. So paths, this is C textures text1.png that read successfully from the YAML file. The type is that true? It looks like the type came back as 1D. So how did that happen? Rows, columns, and count are all 1, but that could just be on accident. So, because the rows, column, and count, those are defaulted to 1 anyway. Okay, so it seems like we've got some parsing problems. I didn't see any warnings inside of the console. Or failures to log from SPD log. So there must be some other kind of oversight happening in my code. I'm going to go to the regular load function, the one that loads that does the YAML parsing, and I'm going to set a breakpoint here. After we have loaded the YAML file and confirmed that's a YAML file. And we'll step through the parsing logic. All right, so for starters, the path we're on is text1. We're looking at texture 1. I will, no, I'll leave that file closed for now. I know what it says. Okay, so the type node appears to be valid. Type node.val. Let me step inside of this function. There we go. String to texture type. The C4 substring that we've got, we can't actually see it. That's interesting. Let's add to the watch window stir.stir. Variable is optimized away and not available. Now I know for sure it's not optimized away. We are in debug build. So I wonder what else could be going on here. I'm gonna stop and I'm going to switch from the launcher version to the standalone version of the game. I'm wondering if static linking will resolve the symbols a little bit better. That's annoying. I can't actually see the contents of string, so I'll have to... Can I... Function has no address due to compiler optimizations, possibly. That's strange. I'm not sure what is causing that, but I don't have the ability to inspect the C4 string type. So I'll just have to step through the logic and see what it picks. It thinks that the string is equal to 1D. How could that be? Oh, because it says 1D. Oh, that's annoying. Okay. Stop and we'll restart this. So, I had, while I was working on these, working on the style of the texture format, I was accidentally leaving it as 1D, even though these are actually textures. Okay. So that should be enough. However, columns, rows, and count, those are 5, 5, and 20, and so those should be set to something else by the time we get to the function. So let's continue. Okay. So the type is now set to 2D, so that's parsing correctly. The string comparisons are working fine. Now we've got the paths. We're going through its children. So num children seems to be successful here for confirming that there's only one element in the sequence. We successfully parsed out c/textures/text1.png, which is what the asset file says. And now we're onto the cube projection. We're skipping right over it because we're not in cubes. Though maybe for the sake of testing, we should comment out this check, so that way it's checking even though we're in 2D texture. I'll come back to that. So here's the columns, rows, and count. Oh, and that's why it's skipping. It's skipping because the type is 2D. Yeah, we have to use a 2D array type in order to set it. So actually, this seems to be working correctly, because it's not gonna warn me about the presence of a slice node or a projection node if I'm not using those types. So in order to test out that we're getting the types that we need, I am simply commenting out the conditions that I placed upon the types. So projection, yeah, we'll do this parsing even though we're not in a cube map. Okay. And now I'll do what I first did, and I'll set the breakpoint inside of the implementation function instead, and toggle off the other F5 time. Five hours and 12 minutes. I think I'm very nearly done. This is a big, long day. All right, so now we got rows 5, columns 5, count 20. Yes, okay. Texture type is 2D. Cube map projection doesn't have a variable name. It's unnamed because I had a typo. This should say projection. And in the textures header, I forgot to put it in there too. Okay. Good. And then I just want to quickly confirm that the projection is reading fine. And in order for me to do that, I needed to actually give a symbol name so I could read it. Projection is split. Good. Okay. And that's particularly good because the default is none, and I know that it's reading split from the file because it says split right here. So perfect. And if I step through each of these files, they all keep doing the same thing. And everything loads correctly. Sweet. Okay, so we still haven't implemented the slicing, the projections, or the other types of textures, but we're there. We're at the point where we can do that. So that's a major step forward. A lot of low-level administrative parsing code to make all this work. But we've now got a scenario in which we can start doing the other types of textures, texture arrays, 3D, 1D, and all that stuff, and decide which we're going to be using from an asset file. That's going to be something that you can source control and change in the editor. And because we now forked off the property setting to another function, we can now change the properties without having to load the texture over again. So we can more easily set up the editor to edit these properties. But yeah, I think we're in a pretty good spot. I'm going to go ahead and call it a stream. I can't believe I did this 3 days in a row, and then today I managed to stay on for 5 hours without losing my mind. I will probably continue to work on this a little bit after I am offline. But yeah, thanks for joining me. Have a good one. I will see you in the future.